Welcome to the NEC Essentials. This is a 6-hour program designed to get the user the CEUs needed in order to renew their license. At the conclusion of this program, you'll be presented with a certificate that you can print or save to your computer, and that certificate will be used as your proof of joining us today in this class. And most likely in your jurisdiction, that proof will have to be sent to your licensing committee in order to collect your CEUs. Thank you, and we'll see you on the other side.
Rule number 1, we'll head into Article 90, which is your basic introduction into the National Electric Code. And it is going to deal with, beginning with, practical safeguarding. Now, practical safeguarding is kind of an interesting subject. Not sit on the edge of your seat type of interesting. However, you got to remember that the whole purpose of the code is to make sure that things are installed properly. It gives us a basic set of guidelines so that you protect the people as well as the property by getting rid of some of the risks along the way that are associated with electricity. So, sum it all up, make sure that you don't damage or burn down the building or injure or potentially kill any individuals that are either working there or that are on the job site for any reason. So again, what are these risks that are associated with the electrical field that the NEC is trying to address? Well, again, it's pretty simple. Don't kill the electrician and don't burn the building down. We are always dealing with electrocution and fire. So as you go through the National Electric Code and you think to yourself, oh my goodness, why in the world did they do that now this year? I want you to sit back and look at it with an objective point of view and say to yourself, okay, is there something that they've done here that has either increased the likelihood that I'm going to make it out of here safely, or increase the likelihood that the building is going to be better off, or the residents in it? So those things are always taken into consideration. Code committees don't get together and look at this stuff and think about how to make your life harder. They get together and try to think how they can make the industry better by increasing the standards without making it more difficult and expensive. Sometimes those things don't lay out that same way. Oftentimes increasing safety and increasing the value to the industry by creating better, more efficient appliances and such does increase the cost, but you've got to outweigh practicality and safeguarding together and make sure that it makes sense. 90.1b deals with adequacy. So what are we talking about here with adequacy? Well, the whole idea of the code is to deal with requirements that are surrounding safe installation practices. Adequacy means that you're installing stuff in compliance with the code, but also in compliance with what the customer needs now. We've all seen some terrible things out in the field. And I want you to keep in mind that the whole purpose behind this presentation and the code book in general and your code officials is to prevent this stuff from happening as often and as unintrusive as we can. Look at this again, adequacy. You can't always plan for how customers are going to use things. The installation that's behind this 6-way splitter is just a regular receptacle, and that was installed correctly. The spacing is right on the wall, the height is fine, You know, everything is installed the way that it should, and it was inspected, so everything was good. Customer takes the cover plate off, puts on a new 6-way splitter, and if this was in a room that had 4 or 5 receptacles that all had splitters on them, we could be causing a potential problem. We could be overloading that circuit because it was never intended to have all those receptacles and things plugged into it. But you can't plan for that. And the only way you can plan for it is if the customer lets you know ahead of time, and oftentimes they do not. So 90.b, dealing with adequacy. The plan for its expansion only comes into play, you know, in the code. You know, now we're talking about what does the code actually say. Plan for expansion only comes from the customer. And code says that your job is to do what the customer needs and deems necessary today and asks for today. It's not your job to drag out of them what they're going to be doing 2, 3, 4, 5 years from now with that same electrical circuit. And they may not know themselves. So your obligation, according to the code, is to plan for today, bid for today. However, your moral obligation is to allow them to make good choices as well. So if you know for a fact there's going to be some expansion, there's going to be things that are going to be going on in that area that are different than what they are today, your moral obligation may be a little bit different than your obligation according to code. Your moral obligation may say, I am going to have to let this customer know that if we planned ahead right now today and I bid him this, even though it's going to cost him more up front, over the long run, it may cost him less because I don't have to tear out what I'm doing today and increase the conduit size or the wire size or anything like that. I can do it all up front today. Those types of things are what we're talking about here for adequacy. Again, you can't plan for what the customer is going to do when you're not there. 90.1c, the intention of the code. Well, what do you think the code's intended to do? Is it designed to be some kind of a instruction manual? Is it designed to be something that your general homeowner can open up and use as a how-to book? Absolutely not. It's intended to be used by people who are already skilled in the trade. It gives us a basic foundational set of guidelines so that everybody's installing things on the same level playing field and with the same amount of adequacy and practicality. If we're all doing the same things, then we should, within reason, be able to have very similar outcomes regardless of where the installation is taking place. Okay, obviously there's one-off situations, but if we're following the code and we're listening to our code officials, we should, within reason, be able to have very similar outcomes from our coparts. It's not designed to be some kind of an installation standard or an instruction manual for somebody who doesn't know what they're doing already. Rule number 2. Rule number 2 is going over the scope. Okay, the scope of the NEC. What does it actually cover? We look at 90.2a, and 90.2a is fairly straightforward as well. The NEC has requirements for the installation of electrical equipment, raceways, cables, and conductors for signaling, fire alarms, optical cables, and communication systems, etc., etc. Okay, there's not a lot wiring-wise that the NEC is not going to take precedence over. So what about warehouses? What about offices? Farms? Farms are always a little bit tricky. What about mobile and manufactured homes? And all of these are things that we need to discuss in order to properly see what's actually covered in the NEC and what's not. 90.2A1 and 2. If you've got private property that has public lighting, it's got to be installed according to the NEC. 90.2A4 deals with utility buildings. And buildings that are used by power utilities, like offices, warehouses, garages, those are still covered by the National Electric Code. They're not exempt simply because they're owned by the power utilities. And that's important to remember. Some people believe just because the utility owns it, it's not going to have to follow any certain set of guidelines or rules, and that simply isn't true. There are utility exemptions, but these buildings and spaces are not it. 90.2B4. Communication utility exemptions. Now, the communication utility exemptions are kind of tricky. If a communication utility equipment, if you have this equipment in a space in a building that's used exclusively for it, it won't be required to follow the NEC requirements. But the National Electric Code is still going to apply to other electrical equipment like receptacles, switches, and luminaires, even in those areas. So that's important to remember because we have guys that work on cell towers and cell buildings all the time. In order to get this exemption, the FCC actually has to have labeled a Verizon or an AT&T or a US Cellular as a communication utility, which consequently those are. But there are some smaller companies that are upstarts that are fairly new that may not be a communication utility. And so everything would be installed according to the NEC guidelines. If the communication equipment is found in general building spaces, so now we've got regular communication equipment. This is 90.2B4, and it's found in regular old building spaces. It absolutely has to follow the NEC rules on the installation practices, and of course a lot of those are going to be found in Chapter 8. 90.2B5A. Exemptions include service drops and lateral conductors if they're under exclusive control of the power utility. Now, I once heard a story while doing a class. We're sitting in class and a gentleman says, well, how do I know where they stop, meaning the power utility, and we begin, meaning the private contractor, when we're doing our service work or even new installation work? In that same class was a power utility gentleman. He worked for the power utilities. He simply says, wherever you're instructed for that location. And he's absolutely right. He didn't have quite as tactful a way of putting it as that, but he's absolutely right. You have to know because different areas start and stop in different spots on the job site. So you have to know what your power utility company expects out of you so that you know where to start and stop and bid your job properly as well. 90.2B5B deals with utility exemptions. The National Electric Code doesn't apply to installations on power utility properties if it's used for generation, transformation, distribution, or metering of electrical energy. That's not a hard one to remember. So as you see, these are the areas that are exempt under the electric utility exemption. However, the areas that we looked at earlier that dealt with the warehouses and the garages, office buildings, things like that, even though they might be owned by this same utility, those are going to have to follow the NEC. They don't fall under the utility exemption. 90.3 will go over the code arrangement, and this will consequently be our rule number 3, and it's an important one. It really is, especially for some of you crossover guys that are going between being an electrician, being a mechanical guy, being a plumbing guy. Some of the other code books don't have as much detail in them because it's not necessary, and so you have a much smaller code book. You have sections that deal with only general area. For instance, most mechanical codes, you're going to have chapter 3 be the general regulations, so everything will follow that unless it's a specific scenario, which everything past chapter 3 sets out a specific scenario. Well, the National Electric Code doesn't do it quite like that. There is so many different provisions out there that the code actually is split into more than one general area, more than one specific area, separate spots for tables and examples, and any time that the code actually references you to another code or standard, it's simply a reference. It's not enforceable. It's there to help you do your job a little bit better. So, getting into rule number 3, the code arrangement found in 90.3. The code's basically designed around the fact that it's a bigger book. There's a lot of information in there, and it has to flow. So they've created really a kind of ingenious flow as to how this is all going to play out. It's divided into an introduction and 9 chapters. Okay, when you look at the chapters, chapters 1 through 4 are general applications. Chapters 5, 6, and 7 are special applications, whether it be special occupancies, equipment, or conditions, makes no difference. We're talking about special circumstances or scenarios. And then once you get into chapter 8 is going to cover your communication systems, and you may find this a little bit backwards, but chapter 8 doesn't have to follow any of the other previous 7 chapters unless there's a specific reference in chapter 8 to those other sections. Consequently, that's different than chapters 5, 6, and 7, which basically modify the general first 4 chapters. So if it's not mentioned in 5, 6, and 7, then the first 4 chapters apply. So it's a little bit different once you get into here, but it's easy to understand once you understand how they flow. Then you've got chapter 9, which deals with tables, and it's not all the tables. It just is very specific tables that really did not fit in the area that they were mentioned, and they are referenced in several different areas of the code. So you don't necessarily have the most popular, most widely used tables, but nonetheless, this is a section that's used fairly often. These tables are running anywhere from raceway calculations and sizings to conductor fills, conduit radius, things like that, tubing bends. All of those things are covered in chapter 9. And then, of course, at the very end of the whole book, you have got the annexes. And the annexes are not enforceable. And just hearing that oftentimes will make an individual not pay attention to them. It's almost like somebody shuts off when they realize that somebody is saying that something's not enforceable. In reality, the annexes are a super valuable source that's found in the National Electric Code because they give you examples that are difficult to understand otherwise. For example, they give you the residential load calculation for the VA in a house. So if you look at trying to figure out lighting loads and your square footage and all that kind of stuff, just going through the NEC, it might be pretty tough to put that all together. Well, Annex D puts together in a nice couple of example calculations to show you from goose to gander how to calculate a residential home. It tells you the derating values, how to figure out square footage VA for the lighting load, what the small appliance circuits are supposed to be accounted for, as far as how much VA they are. I mean, it is absolutely a priceless area in the National Electric Code, but unfortunately, oftentimes people skip over it knowing that it's not enforceable. Okay, they have to go to the code or to Google or something like that in order to find the answer that they're looking for, when in reality it's probably right there on their code app or the code book. So that's unfortunate. First of all, we'll look at the general requirements. These are the first 4 chapters in the code book. And the first 4 chapters are General Rules. Chapter 2 is Wiring and Protection. Chapter 3 are Materials and Wiring Methods. Chapter 4 is Equipment for General Use. Special requirements are the next section. Okay, these are applications that are going to fit in chapters 5 through 7. They're still going to follow all of the requirements in the first 4 chapters. However, chapters 5 through 7 may alter what was said in the first 4 chapters, which would make them, chapters 5 through 7, take precedence in the altered state, because they're designed to be something special. Okay, for instance, you wouldn't want the same application in my living room as you would want in some place that has heavy, flammable, combustible fuels and gases around. That would be a hazardous location. So you're going to alter the actual installation requirements and things like that for the hazardous location above and beyond what would be found in my living room. These chapters are titled Chapter 5, Special Occupancies, Chapter 6, Special Equipment, Chapter 7, Special Conditions. Moving on to Chapter 8, which is titled Communication Systems, is really an animal of its own. The applications in Chapter 8 generally are not bound by the first 7 chapters at all, unless there's a specific reference that sends you back to an early chapter. Okay, which there are many of them. So I don't want to make it sound like Chapter 8, you just go there and you don't need to know anything else in the code. That is absolutely not true. Okay, you still have to know code in order to install DSL or cable systems or any kind of communication system, because you're going to be referenced back to grounding and bonding principles and things like that that are completely applicable in the communication systems. Chapter 8 is actually titled Communication Systems. Chapter 9, Tables. Okay, Chapter 9's tables contain all the different tables that really didn't fit in their respective place actually throughout the code book. They're referenced several times throughout the NEC, and they cover things like calculations and conductor fill and raceway sizing and all the important voltage drop. It's actually titled Tables. Here are some example tables that you will find in Chapter 9. Okay, here's Table 8, Conductor Properties. Table 9. Okay, here is your resistance per 1,000 feet, figuring out power loss and things of that nature. Next, at the end of the book, are the annexes we were talking about. The annexes are not enforceable. However, they've got all kinds of guidelines and suggestions to make your life a whole heck of a lot easier. They take large sections of code that are spread throughout and put it into one little area, oftentimes on a table or in a calculation, to show you how all of those sections are brought together to get you to one endpoint. Totally priceless section of the codebook. The annexes are in alphabetical order from Annex A through Annex J. And we'll look at those here in a minute. Annex A, Product Safety Standards. If you see the very first section here in Annex A, it says, Annex A is not a part of the requirements of this NFPA document, but is included for informational purposes only. Okay, here you've got Table C1 dealing with the maximum number of conductors or fixture wires in electrical metallic tubing, EMT. Okay, here's our example of Annex D, which gives us a one-family dwelling unit calculation. Okay, this is only one little section of it, so obviously there's more to this calculation, and there is certainly more that is given in Annex D. There are several calculations. Here's an extended example of that calculation. Notice you can see your minimum feeder size is going to send you back to 220/40, but you've got your general lighting load, you've got your small appliance load, your laundry load. It tells you what your derating factor is for your lighting load. So I mean, you've got an invaluable source here for figuring out what a residential calculation would be. (90.4) talks about enforcement, and this is our fourth rule. Enforcement is not tricky at all. We've got people in place that are designed to help make the life easier of people that are following the rules. And those that aren't, well, you know how that goes. Their life may not be as easy, and they're usually the ones that are complaining about their code officials making their life really difficult. 90.4 deals with code enforcement. The NEC is intended to be used by the local authorities that have jurisdiction to give fundamental boundaries and safe installation practices for power, signaling, and lighting circuits, as well as communication systems. Pretty straightforward in the code, really. Okay, interpretation of the rules. When it comes to interpretation of the rules, if it's code compliant, it'll be safe. So follow the code. The AHJs aren't there just to impose their will on you. They're there to enforce what the code says, not make their own rules. And they're generally pretty good at it. And we might not always like the interpretation, but that's why we've got these guys in place, so that they interpret these rules for us. They give us a broad understanding of why something is not or is accepted, and then they also give us a good uniform compliance standard. A 90.4 reads, although the local AHJ is responsible for interpreting the NEC, they've got to do so based on their best interpretation of the article found in the codebook. Doesn't pick a whole lot of bones about it. Okay, so if something's not passed, they're going to cite you, but they're going to tell you why it wasn't passed based on the codebook. So in my personal opinion, if you're on a job site and you're doing something a little bit different or out of the ordinary for you or for your company, what I would suggest would be leave the section of the code that you're referencing for being able to do it the way that you're doing it for the code official, so that he can see that you just didn't make up what you're doing. You actually had a reason and an angle for why you did it. They may not and don't have to accept it if it's out of the realm of what's normal in their local area. However, what that does is it builds a good rapport with you and your inspector, because he understands that you are following the code book to the best of your ability, and that you respect his authority in the enforcement of these codes, which goes a long way. The HJ, Authority having jurisdiction. You'll hear that mentioned all throughout the code book. It might be an organization, could be an office, could be one single individual, could be the same individual for electrical, plumbing, and mechanical. Okay, but they're there for the purpose of interpreting the code, and then also for approving equipment and the materials and the installation procedures that you use while done in accordance with the code. So they are our official, and for the most part they do a pretty good job. Approval of equipment. Now, who is going to be in charge of approving equipment? Well, of course it's going to be the AHJ. They're the only ones that have the authority to approve the equipment and materials that are being used. The approval should hopefully most of the time be done based on what the product listing is and your installation standard. So when we're talking about what the product listing is, if it's UL listed or listed by an agency that's approved by your jurisdiction, oftentimes, even though we might be mid-code cycle and we got a new product that hasn't made it into the code yet, they may still accept it. 90.4, compliance with the listings. It's the responsibility of the AHJ to make sure all appliances and equipment are installed according to the manufacturer's guidelines. This is in addition to following the National Electric Code guidelines. This is not instead of following the guidelines, but in addition to. Now, what are we talking about here? Well, let's give a very straightforward example. What happens if following the code violates the manufacturer's guidelines? Okay, well, that's kind of a loaded question because it just depends on if violating the manufacturer's guidelines, if we're talking about that, is it actually going to change the nature of how the equipment operates in the way that the manufacturer intended it to operate? Because if that's the case, oftentimes the manufacturer's guidelines and the UL listing will win. Because if following the code alters the nature of the way that the equipment was designed to run, then what good is it going to be to follow the code? You actually may be losing some of the safety by altering the way that it's running. You might lose some of the efficiency, so it's kind of a fine line when it comes to manufacturer's guidelines and the code, and when they conflict. It doesn't happen that often. But long story short, the best thing that you can do, check with your code official to see what they're looking for in that instance. It's one of those things where they're going to tell you yes or no, you've got to do it this way or you got to do it that way. They're not going to pick bones with you, and chances are if they're going to tell you no when you ask in advance, they're going to tell you no when you ask afterwards. It's one of those things where it's definitely not easier to ask for forgiveness after you've already done it. Oftentimes, that shows disrespect for your code official, and if they were on the fence, they might not be jumping over to your side of it if you've superseded their boundaries. So keep in mind to always speak with your code official before doing anything questionable. Waiver of requirements. Only the HJ can waive specific requirements of the code or even permit any alternative methods to happen. So there are some people out there that are just really full of ideas, and sometimes they have a little bit better way of doing things. Well, if you're one of those people, just because it's not found in the code or it might be a little bit different than normal doesn't mean that the code official is not going to accept your means of installation or your product that you want to put in. They do want to be included because their job is to provide public safety. They don't want somebody to be unsafe because somebody went off the reservation and did something completely sideways of what's considered normal and it made it unsafe. They need to be included into your decisions there. 90.4, waiver of new product requirements. If the code requires products that aren't available yet, then you're going to be allowed to follow products that are acceptable now or were currently acceptable with the previous code, until the new product is out. And then the code official might say, yeah, okay, you're going to go ahead and do it the way you've always done it, but when this new product comes out, you're going to have to start using that. We've seen that several times through the years. Probably the most recent was the advent of Gfcis and arc fault circuit interrupters. You know, the actual arc fault receptacles took for quite a bit longer than the actual breakers to come out. And when the breakers and the receptacles both came out, you could follow several different sections of the code as far as having options on how to install in those areas. But there were some overlap there to where there were requirements that said you could use receptacles here, but they weren't available, so you were able to use the previous requirements until they became available. 90.5 Mandatory Requirements and Explanatory Material. Getting into 90.5, which leads us to clarity on terms. And clarity on terms is quite a big portion to deal with, but we're going to make some fairly short work of it. Shall or shall not is mandatory. Very simple. So it's a very, very important part to remember in the code because it's spoke about throughout the code. But again, like I said, we're making short work of it. Shall be permitted means you can do it, but you don't have to. References to other codes are informational only, but they are not enforceable. 90.5 Approvals and Explanatory Material. Remember, product evaluations are done in a lab. They're not done out on the job site. If the product is listed or labeled or identified in some way that's recognizable and acceptable to the authority having jurisdiction, generally it's going to be accepted in that area. 90.7 Examination of the equipment. Usually an inspector might look at a factory installed or designed panel for its UL listing to make sure that it was actually designed and listed for its purpose, but usually they're not going to get too enthralled in checking all the circuitry unless you've altered it somehow. So if you've actually got into the panel and put holes and other relays or circuitry inside of the panel in addition to what the factory has done, if you didn't do that, they probably are not going to get too whipped up about what you've got installed there. Rule number 6, General Requirements. Article 110 deals with the requirements for electrical installations. And more specifically, 110.2 deals with the approval of the equipment. You should only install approved conductors and equipment, and they are supposed to only be installed by approved methods. Okay, with that being said, the HJ has the ability to approve all of them. The conductors, the equipment, and the method by which they're installed by. 110.3b pertains to the installation instructions. Your equipment has to be installed and used as the manufacturer intended. Again, as we spoke about just a short while ago, if the manufacturer's instructions are different than what the code says, and following the code would potentially violate the manufacturer's installation instructions or the UL listing, then chances are you're going to get a pass on that. But it's always important to make sure that you understand where your code official stands on the subject. 110.3b. make sure that you don't ignore anything, right? It's a violation of the code to ignore listing and labeling instructions found in the code, even, of course, if there's something that you don't agree with. And yes, I have a table here, table 1.1, that deals with torque specs. The torque specs are something that oftentimes get overlooked, and I hear service technicians or installation crews kind of chuckle when we start talking about them, but they are important. They're there for a reason, and even though you might not agree with them, you are supposed to be following even the torque specs. Look at some of the things that are on these labels here. For instance, in the upper left hand corner you see an air conditioner nameplate. Notice where it says maximum fuse or breaker size. Okay, if it says maximum fuse and that's it, with no breaker size or anything like that on there, just maximum fuse size or something like that, that's a command. That's telling you that even though you might have a breaker on the other end, that you have to have a fuse, even though it's going to be redundant, in that circuit. So those things are really key to hone in on and understand what the manufacturers actually wanted. This particular one says fuse or breaker. Notice here on the right hand side we've got a torque screwdriver, which is very popular. Makes short work of having to torque some of the smaller receptacles and things like that, because even the receptacles are going to have torque specs for the screws, usually going to be in the manufacturer's installation guidelines. You can see here on the lower left hand corner where the receptacles are that you've got all kinds of things indicated on there. You've got your listing mark, the maximum amperage that it's designed to run at. You've got what type of wire is allowed to be hooked up to it. So there's all kinds of things that you'll find imprinted on the device or on the installation instructions or the manufacturer stickers that you're going to have to comply with. Okay, oftentimes you'll see this in residential settings. I would say quite often. Take just a moment and let that sink in. Look both up at the top left and the top right, and you'll see two non-metallic cables or Romex going into these panels, and they're doubled up under the connectors. So why is that frowned on? Well, code says that you're only supposed to have one wiring method per connector type, unless it's listed for something different. You know, if you can have multiple wires and it's indicated on a UL listing or something like that, that's fine. Okay, but these aren't. When you go from older residential dwellings to newer residential dwellings, we have so many new circuits that people didn't have decades ago. We have a lot more things that plug in. We have ceiling fans, lighting everywhere, special stuff that they just didn't have room in the old boxes for us to hook up all of this new stuff. And so you'll see guys that'll go in there, do a renovation or something, and they'll have to double lug or change the box. Okay, so let's talk for just a second why they don't want you to double these things up. Why is that? I mean, obviously you can get them tight. If you've ever been back to the shop, you see the lower right or the lower center picture here. You've tightened these things down, you can't move them. I mean, it all but pinches the wire to death. So why isn't that good enough? Well, one primary reason, remember all the way back to the first couple of minutes that we spent in the program here, we talked about two things that always go into the code: protect the people, protect the structure. One of the things we're looking at here is structural integrity. Okay, right now, as it sits in that lower middle picture there, that non-metallic cable is taking up the entire fitting. And if you look at it, you would see, if you could move it all around, you'd see there's no light going through there or anything like that. It's very, very tight. However, if you were to take a torch and burn all of that plastic flammable material off of the actual wire, you would notice that there's hardly any area inside of there that's not taken up by that plastic sheathing. So if a fire were to occur and burn all the sheathing away, there's a huge gap in there where the wires run through that. And so if a fire were to break out inside of the panel and burn all the sheathing away, and you had two non-metallic wiring methods doubled up in one connector, there would be a huge gap that fire could spread outside of that panel up in through the joists and to the rest of the house. So that is one, and should be adequate enough, reason as to why they don't want you to do that. Sure, it costs more money to put in a new panel and such, but we're talking about structural integrity. Rule number 7, 110.14. We're talking about electrical connections now. So in dealing with electrical connections, what are we talking about? Well, look at this breaker that we've got right here. This breaker has all kinds of things written on the manufacturer's sticker right on the breaker itself. Okay, one thing that we're looking at is temperature limitations, right? And I've got that highlighted there. But also on there, you've got the manufacturer part number, you've got your UL listing number and everything. You've got all kinds of things on that manufacturer sticker. If you look at, if you were to look around on that breaker, you would also see that there are temperature limitations, right? 6, if we're talking temperature limitations, generally nothing or a 6 will indicate 60 degrees Celsius, and that would help you size off of the table 310.15b16 for sizing your conductors based on ampacity. And if it has a 7, it's referring to 75 degrees Celsius column on that chart, and if it's a 9, it would indicate 95 degrees Celsius. So let's look at a couple examples of the different markings that are found on those products. Okay, first of all, we got torque specs. Same breaker, other side. We got torque specs that are stamped right on this device itself. And having those torque specs stamped right on there makes it so there's very little, if any, you'd have to really stretch to have an excuse to not actually torque your lugs. Okay, if you're wondering more about torque specs, okay, 110.14a speaks about them, and then there are other manufacturer specs that you'll find in Annex I. Okay, table 1.1, there's your, table I.1 is your tightening torque specs. Electrical connections, still we're continuing here. There's all kinds of information. This is off that same breaker. Shows you the kind of wire that you can hook up to it. Notice you see the CU/AL. Okay, there are different ways that the industry indicates whether or not you can use copper or aluminum or either one. Usually CU or CO will mean that you can use copper. AL or ALR is used for aluminum. So if it says ALCU or COALR, that's going to equal copper or aluminum. That slash in the middle is an either or. Okay, very few devices, fittings, connectors, etc. allow you to intermingle aluminum and copper. There are some out there. This is one set of twisters that is produced by Ideal Products, and this allows you, right off the manufacturer's website, it allows you a secure connection for aluminum to copper, and it doesn't lead to any kind of aluminum corrosion, prohibits it. Okay, so this is one indicator that should be pretty widely known for you already, that putting aluminum to copper is not acceptable in all matters, but there are some circumstances and some fittings that you can use. Electrical connections, still in 110.14. Okay, you'll notice that on the back of this receptacle, you'll see the 10 to 14 gauge wiring indicator on there, which is telling you the size of wire that you can have hooked up to it. The type of wire is telling you copper only, and it also says AL with a slash through it, indicating that no aluminum is allowable. Okay, looking at the temperature rating on this, okay, typically the temp rating and type of the metal wire that's accepted will have to be a visible and undamaged for the AHJ to accept it. If it's been all scraped up and it can't be read, then it's going to most likely be assumed to be copper only at 60 degrees Celsius terminals, which is the safest rating that an AHJ would be able to give you. Okay, 110.14a, terminals with more than one connector have to be identified. Okay, what do they got to be identified for? Well, they got to be identified to be acceptable to have more than one connector on there. So double lugging is not acceptable either. A lot of people don't consider grounds and neutrals to be included in this ruling, but that's absolutely a false statement. Neutrals and grounds are still considered to be conductors. Here's another example. Most people don't have a problem including the hot wiring or the hot wires in this rule either. Okay, so if you look, terminals for more than one conductor and terminals for aluminum shall be so identified is actually pointed out in this section of code, 110.14a. Okay, and you'll notice center stage right there in the middle of the screen, our mains coming in are double lugged. Okay, in reality, if you got a conductor, regardless of the color, okay, whether it's hot, neutral, or ground, they're all included in 110.14a. So make sure that you're taking care of the situation and not double lugging these up. There are some acceptable measures for putting more than one conductor onto a terminal. So it could be that the manufacturer of the terminal just has simply okayed it. So you can have more than one conductor on there. Okay, it could be that you've got one connector that's split into two actual connection points like these all have in the ones marked yes with the arrows, so that you're not actually double lugging anything, but you are making both connections on those actual connectors. When it comes to splices, 110.14b, conductors are to be spliced or joined, and they're supposed to be joined or spliced by devices that are listed for that purpose. Now, one thing you've got to keep in mind when you're looking at this stuff, okay, when you're splicing, the basic rule to follow is when the product is finished being spliced and then reconnected, it must be mechanically sound, okay, so you're not going to pull it apart, and it also has to be electrically secure as well, and it has to have the same insulation value that it had for the circumstance before the product was actually spliced. As you'll notice here, we got a regular box of wire nuts, and it says right in step 3 here that there's no pre-twisting necessary. Now I run into that all the time, and it's not that it's an unusual argument. Arguing about things such as this when it's fairly clear on the manufacturer guidelines right on the outside of the box is just kind of a little bit silly. Okay, so in looking at this, where did this all come from? Well, if you've got bigger wires, then using something to help you twist the wires before you put the larger wire nut on there, okay, may actually aid in doing the process and making it secure. However, it's not mandatory. I once had a gentleman that was really set on the fact that you had to have a minimum 6 twists with a set of pliers, and then you also had to have several twists with the wire nut before it was considered to be electrically sound. Now, there is no such detail in the code book. It just has to be electrically secure and mechanically sound, and have the same provided insulative value as it did prior to being spliced in the first place. 110.14b, splices still. The insulation provided by the splicing device or connector has to have the equivalent protection provided by the conductor itself. Okay, here's some examples of some things that went sideways. As you will notice, there are both aluminum and copper wires inside of the wire nut and inside of this particular outlet, and it really led to a gigantic amount of heat built up inside of the system, and that amount of heat has melted the wire nut and could potentially have caused a fire. It's awfully difficult to say. From 110.14b, continuing on with conductor splices. Okay, in the code, we're talking about the splicing, same section that we've been talking about for the last few minutes. Multi-conductor type UF or type USC cable can be spliced underground with the listed splice kit that encapsulates the conductors and the cable jacket. There's a common misconception that you can't splice underground conductors, and that's not necessarily true, as long as you keep in mind one of the basic rules, which says you have to have the same insulative value as you had before the splice was ever made. 110.14c talks about temperature limitations. Conductors are to be sized to the lowest temperature rating of any terminal. Notice we've got the 9 on there, pretty much dead center in the screen, and that 9 is indicating 90 degrees Celsius. 110.14c1a equipment provisions. If the equipment is rated 100 amps or less, or marked for 14 gauge or 1 gauge conductors, termination shall only happen if one of the following is true. 1. The conductors are rated for 60 degrees. 2, the conductors that have a higher temperature rating, but the ampacity has been calculated using the 60 degrees Celsius column of 310-15B16. 3 and 4 are not mentioned because, we don't use them that often. It's very obscure. Again, this is 110.14C1A. You're certainly welcome to reference this on your own, but again, they're very obscure. If you wanted to know what they are, 3 says if the equipment is listed and identified for the conductors being used, and 4, if you've got motors with a design rating of B, C, or D, and the temp rating of 75 degrees Celsius is permitted provided the amp rating doesn't exceed the 75 degrees Celsius column rating of 310-15B16. So very obscure rating there. 110.14C1B. We were just talking about A, now we're in B, and we're dealing with equipment provisions. If the equipment is rated 100 amps or more, marked with 1 gauge, conductors or larger, termination shall only happen if one of the following is true. The conductors are rated for 75 degrees Celsius. The conductors that have a high temperature rating, but the ampacity has been calculated using the 75 degrees Celsius column of 310-15B16, or the equipment's listed and identified for the conductors being used. Rule number 8, 110.16 Flash Protection Warning. 110.16 deals with arc flash hazard warnings. More particularly, we're going to get into the labeling here coming up. Arc flash warnings have to be located in a visible location for a QP, which is what? A qualified person. Okay, now that is different for some of you that are used to hearing a competent person on the OSHA or safety side of things. Now, a competent person is somebody that simply is named by a person in a superior role. They may or may not have additional training. They may not initially have elevated understanding of the situation or the hazard. But that's different than a qualified person. There's actually measures that have to be met before a person can be considered a qualified person. 110.16 arc flash warnings. And other than dwelling units, electrical equipment that could be tested or worked on, which is a huge indicator as to when it's actually applicable, requires a factory or field marked arc flash hazard warning sign. The sign has to meet the requirements in 110.21. So let's look at 110.21b, which is your reference point. What items are required? Well, you warn of the hazard using effective words, symbols, or colors. It's got to be permanently fixed. It cannot be handwritten. And the exception to the handwritten rule are items that are subject to change. So if you've got items that are subject to change, the handwritten rule or policy can be negated. It's got to be able to hold up in the environment, so the conditions that are in are going to really dictate what type of sticker we're talking about. Informational note, NFPA 70E is an invaluable resource. 2015 is your most current right now. It comes out staggered in years from the National Electric Code. So the next National Electric Code should be out in 2017. So your next NFPA 70E, which is the electrical safety standard, will come out 1 year later in 2018. It contains the guidelines for the electricians when you're talking about determining exposure potential, safe work practices, arc flash labeling. It also gives great advice on how to select the appropriate personal protective equipment. Here's another example of an arc flash sticker being put on. Here are some personal protective equipment selections that you could make. Notice left to right, they get a little bit more intense. Okay, here are some other options once you really get into the arc flash scenario. And one thing that's very important to remember, and you could spread this on to your mechanical friends. Oftentimes when our mechanical friends are up on a rooftop or on a side of a building working on a commercial structure, or in some instances, depending on the area of the country, maybe even a residential structure, that is an elevated amount of voltage. Say you got 480 volts. Oftentimes they're not wearing anything to protect them from an electrical shock. Well, the requirement to wear arc flash protection is not just for the safety of the electricians, it's for everybody that's going to work on or test these high voltage products. So make them aware that this is something in their monthly safety meetings that they could be practicing and researching how to use properly out in the field for their own safety as well as everybody else. Okay, here is a nice indicative caricature of what it looks like as far as an arc flash, what actually happens. We've all seen some of the photos, and we'll have some coming up, of what happens when an arc flash occurs, but there's a lot more science behind it than just the flash and the molten copper and aluminum that shoot out and the electrical charge. There's a sonic wave. There is all kinds of things that go into the behind the scenes study of this stuff, and trying to decide what kind of personal protective equipment somebody should wear is really difficult if you don't understand these different principles that are at play. Notice on the left here we've got rainwear that has non-meltable material. On the right we've got rainwear that has meltable material. Okay, now chances are both individuals are going to endure a high amount of heat. Okay, but the point is, the personal protective equipment that was designed to handle the high amount of heat actually worked. So we may have saved the person on the left over the person on the right. And you got to remember, a lot of these studies that they're doing now is not specifically designed only for electricians. It's also designed for general maintenance men and janitorial men and women, because they're going to be on the job site just as much as an electrician, so they need to know, okay, what is our baseline personal protective equipment that these individuals should be wearing. Maybe they're not going to have a 500 cal suit on all the time. Okay, but what could they be wearing that could save their life in the event of something going sideways? Okay, this one here, courtesy of Fluke. Okay, if you look at these two pieces of clothing here, you got two very similar incidents, two very different outcomes. You've got arc rated personal protective equipment or personal protective wear on the left hand side, and you've got regular fabric on the right hand side. Okay, here is a picture. You go top left and then across to the right and then down to the left, middle, across to the right, down to the bottom left, and across to the right. And you will see that this individual, after following that sequence, which this is a mannequin, this isn't actually a person, but this individual would have probably survived. Okay, this is out of NFPA 70E. And you look at this sequence of events here. It shows an arc flash from the initial fault to after it's been extinguished. The initial fault happens there in picture number 2, upper right hand corner, and it's ugly. It's really a huge amount of heat, molten metal, probably shards of metal and gases, a huge pressure wave, all the way down to the last picture there, which shows that this individual may have made it because of the personal protective equipment that he was wearing. Obviously, this is what we are trying to avoid. Okay, this is the purpose behind the code, is to save the structure and save the people involved, all the people involved. One 110.22, identifying the disconnects. This is rule number 9. 110.22a, general overview. Each disconnect has to be identified as to its purpose unless its location makes it clear. 110.24, available fault current, which is rule number 10. 110.24a says in other than dwelling units, the service equipment's got to be marked with the maximum available fault current, and it must initially include the calculation date as well. (110.24b) says when it comes to modifications, if the modifications could affect the electrical installation's maximum available fault current at the service, it has to be recalculated and relabeled. With the exception at 124A or for 124A and B, they aren't required in industrial installations when it's clear that only a qualified person will service that equipment. So it's not in an area where general passersby or the general worker bees will be able to get into it. (110.26) Spaces about electrical equipment. Rule number 11. (110.26) Spaces about electrical equipment. Sufficient space to work on or maintain electrical equipment is required. It has to be kept clear and safe from obstructions all the time. (110.26a) talks about working space. If the equipment is working at less than 600 volts or less to ground and could become energized, so we're talking 600 volts or less to ground and could become energized, doesn't say it is energized, but it could become energized, while being examined, adjusted, serviced, or maintained shall comply with 126A1 and A2 and A3. Okay, 110.26A1 talks about these working spaces. If you look at it, the one that we're going to focus on is your nominal voltage to ground being 0 to 600 volts. And you'll notice that there are two distinct separations here, where you got 0 to 150, and you got conditions 1, 2, and 3, and then 151 volts to 600 volts with conditions 1, 2, and 3. A1, dealing with the depth of working space. We got two basic voltage ranges that we're working with here. We've got the 0 to 150 volts at a 3-foot distance, and 151 to 600 volts working at 3 to 4-foot distance. Now, what I'm talking about here is, if you were to look at that chart again, and we'll explain it with a picture here in a moment, if you were to look at that chart again, it doesn't matter whether it's condition 1, condition 2, or condition 3. 0 to 150 volts is still going to maintain 3-foot distance. However, if it's 151 to 600 volts, those conditions change the distance between the two devices. This is what we're talking about. Condition 1. Condition 1 says we've got live parts on one side and it's insulated on the other side. In that instance, 0 to 600 volts is going to equal 3 feet. So it doesn't matter what the voltage range is, 600 volts and below, it's a 3-foot distance. Condition 2. If you've got live parts on one side and grounded parts on the other side, Then if it's 0 to 150 volts, it's going to maintain that 3-foot minimum clearance. And if it's 151 volts to 600 volts, it's going to increase the amount of distance you have to have between those two objects. It'd be 3.5 feet. Condition 3 talks about having live, potentially exposed parts on both sides. This would require still a 3-foot distance if it's less than 150 volts, or if it's 151 to 600 volts, it's going to have to increase the space between those objects to 4 foot because of the increased amount of danger or potential for danger. Notice our spacing here. There's all kinds of stuff going on in this picture, but some of the more questionable areas would be towards the back of this room. Now again, looking at this, I'm sure that most of these things that are in this room were added after any kind of inspection. However, doesn't change the fact that we do have potentially dangerous situations here with those meters in the back. Now, obviously, things have certainly gone sideways here. We've got some service coming in here, and it is all over the place. It looks like potentially there's some mold on the wall, maybe some mildew on the wall, and so we've got some moisture down there. Things are rusted. We're below level, so we've got all kinds of things going on in this picture here that makes the installation probably not comply. Now, what do we got going on here? Hey, notice we have no cover on this box. Everything is exposed inside of there. There's no, because of no cover, and we have the potential, that's a gas pipe there. We have the potential of a leak, possibly followed by an electrical spark or arc, leading to all kinds of not good. Here's a few different things that come up from time to time. Now, I'm not going to tell you the one in the upper left comes into play all the time. Somebody really had to want to play a trick on somebody. That condensing unit for the air conditioning system is upside down. So very unusual that somebody would do that. The one in the upper right, however, comes into play all the time. You can see clearly this is on a rooftop. They have the disconnect hooked right to the condensing unit. It is on a panel that is a removable panel. That panel is able to come off in the event that we have to make a repair on the condenser coils or need to clean the condenser coils. So you could be subject to having to do something a little bit different there. Putting it on some kind of a fixed 4x4 coming up through the ground, or stabilized on the rooftop or something like that. You know, something other than on that condensing unit. I'm not going to say that this wasn't inspected and accepted, because some inspectors are fine with that, but other ones are not, and that's why you have to ask your inspector what they would accept and what they wouldn't. The one in the lower left is just silly. Mechanical code and most codes actually indicate that you have to have 30 inches wide, 30 inches deep of a working space in front of the serviceable panels. This guy clearly does not have that in that lower left-hand picture. If you notice really clearly, there's somebody holding that guy. You can see his arms wrapped around his waist from inside of that building. And then the lower right one has been around for a little while, but always interesting. Caption on that really should read, who should you call? Plumber or an electrician? 110.26A1A, dead front assemblies. You don't have to leave the room or leave any room for working space in the back or the sides of the equipment if all the connections and the work and testing can be done from the front of the equipment. (110.26a1b) low voltage. If the AHJ gives you some permission, the working space can be diminished if the equipment's not operating at more than 30 volts AC or 60 volts DC. 110.26a1c deals with existing buildings. Now remember, existing buildings fall into a gray area that basically, under normal situations, you would be exempt from following a lot of the new code standards if your building was up to code when it was built or at last update. So just because your code changes doesn't mean you have to bring all the building and structure up to current code. That would be very expensive for building owners, and I would have a feeling that we would see a lot less small business folks that would work outside of the house than we do right now. But when it comes to existing buildings, if written policies are in place to prohibit both sides of a walkway that contain energized parts on both sides from being opened at the same time, the AHJ can grant less clearance in existing buildings. So you've got a walkway, exposed parts that are on both sides, or energized parts on both sides, and there has to be some kind of a policy in place that makes it so that they both can't be exposed while energized at the same time. 110.26a2, the width of the working space. For equipment 30 inches wide or less, the working space has to be at least 30 inches wide, even if the equipment is less than 30 inches. 110.26a2, the doors have to be able to be opened to at least a 90-degree angle. And if equipment is over 30 inches wide, then the new working space, instead of being 30 inches, will then be the width of the equipment. So it's going to be at least a minimum of 30 inches, even if the equipment's only 15 inches wide. You've got to have 30 inches there. However, if the equipment is 6 feet wide, the new working space is now 6 feet. 110.26a3, the height of the working space. For equipment 6.5 feet tall or less, the height has to be 6.5 feet from the floor, grade, or the platform, minimum. There is an exception. If you have an existing dwelling unit with a service that has less than 200 amps, which could be fairly common in mobile homes and manufactured housing, the AHJ could permit the height requirement be less than 6.5 feet. Again, this all goes back to being in contact with your authority, having jurisdiction, your inspector, and understanding what he's okay with and what he's not. If the equipment is taller than 6.5 feet, if the equipment's taller than 6.5 feet, then the new height of the working space is going to be the height of the equipment. So you got to have a minimum 6.5 feet without the authority having jurisdiction giving you any clearance for less than that. So minimum 6.5 feet, even if it's 3 feet off the ground, you got to have the minimum 6.5. However, if your equipment is 10 feet tall, the new height of the working space is 10 feet from the floor or grade. What about having stuff mounted above or below? We see this a lot. It's okay to have other electrical equipment above or below, but in the same working space, height-wise, of course, as long as it doesn't infringe more than 6 inches beyond the front of the electrical equipment. This is probably one of the least favorite portions of Article 110 for most electricians. It allows people to store stuff in the area that has electrical equipment. 110.26b says nothing is allowed to be stored in the areas designated as the working space. However, it can be in the same room as the electrical equipment as long as it's not in the qualified working area, working space, and if parts that are normally enclosed and are exposed only in the event of needing repair or checking, and they're guarded. So if you've got parts that are normally going to be guarded and are only exposed for inspection and repair, you're good to go. 110.26c talks about entrance and egress from the working space. 110.26c1 talks about minimum requirements. At least one entrance is required to achieve 110.26c1. Most people don't realize that the requirement's only one entrance and egress unless you're over 1200 amps and over 6 feet wide, and it contains switching, overcurrent, or control devices. And unless 110.23c2a or b are met. So your minimum requirement is one entrance. 110.26c2 deals with large equipment. If it's over 151 volts with live parts on one side and grounded parts on the other, you got to have at least 3.5 feet of workspace on the front side of the equipment. We talked about that already. Okay, and we're talking about equipment that is big. Look at the parameters, 6 feet and 1200 amps. If the location allows an unobstructed entrance and exit, only one method of entrance and egress is required. That's C2A. 110.26c2b talks about extra working space. If the workspace required in table 110.26a1 is doubled and the distance from the equipment to the nearest edge of the entrance or egress complies with that same table, you only have to have one entrance. One 110.26c3 deals again with large equipment. The equipment that are 800 amps or more and less than 25 feet from the closest edge of the working space, those entrances and exits have to have panic hardware. Now, we've seen panic hardware forever, but remember, it doesn't always have to be the big old bars like you see in the left-hand side here. Okay, those are usually preferable because it covers the whole side of the door. You could literally fall into it without the use of hands or sight and fall out of the structure. But the requirements have been loosened up in quite a few areas to where now paddle handles, like you see on a common household, however, that can't be locked, are also acceptable. One 110.26d, illumination. Indoor electrical service equipment has to be illuminated. It just has to. If you're going to work on it, you're not going to use a miner's light or something like that unless there's no power to the room or you're in an outage or something like that. But any automatic illumination, which is so popular nowadays, having the occupancy sensors and whatnot, they have to be able to be overridden. Okay, what would be worse than having your hand inside of a panel and concentrating on moving, but not, or on the checking of the equipment, but not moving enough to maintain the occupancy sensor, and it shuts off. and you've got to take your hand out of a live piece of equipment and wave it so you get light again. That would be absolutely a horrible feeling. So the 110.26d illumination area that we're talking about here is talking about these occupancy type sensors, and it says that you can have them in those areas, but they have to be able to be overridden in the on position. 110.26e talks about dedicated equipment space. All switchgear, panel boards, motor control centers have to be in a dedicated space and protected from damage or comply with E1 through E2. Well, indoor installations also must comply with 110.26 E1A through D. So what is 110.26 E1A? Dealing with dedicated electrical space. It says dedicated space is different than working space, okay, because it refers to the actual width and depth of the equipment, and a space equal to that's got to extend from the floor to 6 feet above the equipment or the structural ceiling, whichever's lower. And when it comes to structural ceiling, we're not counting ceilings with removable panels, such as drop ceilings. So you have to keep that in mind. So 110.26 E1A, dealing with dedicated electrical space, it extends beyond the top of the equipment, 6 feet, or to the top of the ceiling, whichever comes first. The exception, suspended ceilings can be in the 6 foot zone. Remember that. Remember that this is indoor, not outdoor, and no piping, ducts, leak protection, or any other equipment can occupy this area. 110.26 E1B talks about foreign systems. Okay, and here an example would be a condensate pipe. You can have materials and foreign equipment above the dedicated equipment space as long as you take measures to make sure that if something goes wrong, like a leak in a condensate pipe, you have protected the electrical equipment below, either with a shield or some kind of barrier or something like that. But keep in mind, you have to ask the AHJ. It has to be approved by the AHJ in order to make this okay. 110.26 E1C deals with sprinkler protection. Sprinkler protection is allowed for the dedicated space as long as it complies with section A and B. 110.26 E1d Suspended ceilings. If the ceiling, like a drop or a suspended ceiling, doesn't add structural integrity to the building, it isn't considered to be a structural ceiling. That's why we were talking about earlier, just a few minutes ago, about your dedicated working space above the actual equipment. It extends 6 feet above the equipment to the ceiling, or 6 feet, whichever comes first. So if the ceiling is at 10 feet above the equipment, you only have to go up 6 feet. But if the ceiling comes first, that's fine. But you can't consider the suspended or drop ceiling to be your structural ceiling to end that dedicated space. They can be in the 6 foot zone, but they can't be considered the top of the 6 foot zone. 110.26F, locked equipment rooms or enclosures. Okay, this is always a big area of contention. Should we or should we not be allowed to lock the equipment rooms? Well, there's some people you just don't want in there. You don't want to leave it open for anybody to get in there. You only want qualified people in there, or you have to have access to it. Okay, so the code has incorporated for quite a while now 110.26F, which deals with that. If you have a locked or secured electrical enclosure, it shall be considered accessible to a qualified person. Okay, because that qualified person will probably have access to it. Key, thumbprint, eye scan, whatever the case may be, a qualified person is going to have access to that. It is intended to give clarity to words that are fairly foundational or essential to understand when interpreting the NEC, but it's not designed to include definitions that are going to be for commonly used words, unless the commonly used word is one that's commonly misinterpreted or misused. If the NEC doesn't define a term that you're looking for, well, it's okay to get that clarity from another code book or a dictionary or a trade book of another sort that's going to be acceptable to your inspector. Now, this happens quite a bit. Not every definition is going to be in the electrical code book, but you'll be able to find it somewhere. Give you an example, the difference between a dwelling unit bedroom or a sleeping room. Those things can have distinct variances, and you'll be able to find definitions to them in several of the different books. But to narrow it down, the sleeping room, you're probably going to have to look in the building code. Accessible, when you're talking about equipment. Allowing a close approach and generally not guarded by elevation, locked doors, or anything else. Accessible wiring methods. Not permanently closed in by the structure or the finish of the building, and they can be taken down or removed without damage to the structure. Readily accessible. This is a pretty common example. We see this often, not only in our houses, but also in laundromats and public use facilities in multifamily dwellings. You can see there's a plug-in right behind that dryer. And in looking at that plug-in, do you feel that that would be readily accessible? In fact, looking at that electrical panel over the top of the counter, do you feel that that would be readily accessible? Code says in order to be readily accessible, it has to be capable of being reached quickly without climbing on or over obstacles for the purpose of inspection or energizing or de-energizing or for service. And one of the additions to the code in 2014 also says that you can't consider it readily accessible if tools are required to access it. If you've got a multifamily dwelling unit and your equipment's located on the second floor, it can still be considered readily accessible as long as it meets these requirements. So it doesn't have to be on the ground level. Ampacity. Ampacity is the maximum current in amps that a conductor can carry continuously without exceeding its temperature rating for the application it's being used in. Appliance. Equipment other than industrial that is normally in standardized sizes that is designed to perform one or multiple functions. This could include a furnace, a stove, or a dryer. Approved. Acceptable to the authority having jurisdiction, usually the electrical inspector. And of course we abbreviate authority having jurisdiction with AHJ. Always discuss any changes or alterations or special methods with your AHJ. Arc fault circuit interrupter, or AFCI for short. A device that's intended to provide protection from the effects of arc faults. So what are those effects? Well, a lot of times it's going to be heat that will lead to fire. If the arc is recognized in the circuit and is de-energized, of course, it's going to get rid of that fire hazard. As we spoke about in several of the other chapters and several of the other courses, we got two things we're looking at here in the electrical code. Two things that the code basically surrounds. Don't kill the electrician. Don't burn the house down. Hey, what makes an arc fault circuit interrupter different than just your regular run-of-the-mill $3-4 breaker? It has a chip. It has a chip inside of it that recognizes the characteristics of an arc fault. And we'll come back to that. Here's an actual arc fault breaker. Notice the neutral pigtail that comes off. The one thing that is different about an arc fault breaker from a normal breaker is both the hot and common will hook up to this breaker, and then the neutral will come right off of the breaker here with this pigtail to a neutral bar. Here are some other examples. Now, in the clear example down here in the middle bottom, you can actually see the chip that's inside. Some of the guys will complain that you get more neutral nuisance trips with an arc fault breaker. That's not necessarily the case as time goes on. The longer time goes on, people can turn in problems that they're having with these breakers, and they can program that into that chip and make it a normal scenario if they can reproduce it in a lab. Similar things have happened in the past with GFCIs. Attachment plug. A device, when inserted into a receptacle, establish a connection between the conductors of the attached flexible cord and the conductors connected permanently to the receptacle. Bathroom. An area, not just a room, an area including a basin and one or more of the following. Could have a toilet. How about a urinal? Or a tub? Even a bidet has been added. Bonded. Connecting conductive, potentially current-carrying objects together, make sure that they don't have any difference in potential. Now, when it comes to bonded, grounding and bonding is a big section of the code book. Always remember, bonding is connecting stuff, whereas grounding is connecting to the earth. Here's some examples of bonding. Again, connecting conductive, potentially current-carrying objects to make sure that you have good connectivity and conductivity. Notice the bonding wires going from one pipe to the other, in both the copper on the left and the gas pipe on the right. Bonding conductor or jumper. Maintains electrical conductivity between metal parts of the electrical installation. Notice in the picture that we've got a jumper because it's possible with the flexibility of that jumper, it could go from one spot to the next on just a regular stationary fixed in place device, but you also could have something there that may move a little bit. It may shift, expand, contract, vibrate. Oftentimes you'll see that on devices that have a flexible bonding jumper like that. Main bonding jumper. Connector that ensures continuity between the grounded circuit conductor and the equipment grounding conductor at the service. These could be a screw, a conductor, or a strap. How many are there on each system? Only one. That's why they call it the main. If you have more than one main bonding jumper, because you're connecting several panels into one system, you'll need to disconnect all but one of those main jumpers so that you don't create a current on the metal parts. Branch circuit. Conductors between the final overcurrent device, like the breakers, and the outlets. This would start at the breaker and end wherever the load's connected. Multi-wire branch circuit. A branch circuit with two or more ungrounded conductors having a voltage between them. Okay, here we got the red and the black, with an equal voltage being between the ungrounding conductors and the neutral conductor. So notice in this particular example, looks like we've got a 240 volt breaker, and with that we've got a hot leg coming off each side going to, black one goes to two different receptacles, red one goes to one receptacle, but they share a common or a neutral. So the days of seeing this often are going to go by the wayside at some point, at least for the time being. It's not frowned upon, it's not an illegal installation, but until we get under wraps the arc fault breakers and the GFCI breakers that need to be installed in many of the areas where these already exist, you're going to start to see them fall by the wayside, especially in the new construction. Existing homes, they're there and they're probably not going to go anywhere for a while. However, the more you need to hook up the GFCIs and the arc fault breakers, the more you're going to see just regular single circuits like is a traditional way. One of the advantages you get from a multi-wire branch circuit is obviously, as you can see from the example, you would have the potential to use less wire, and you would also have the potential of running multiple circuits off of just one breaker. So you can do a lot more stuff inside of that panel. However, the downfall on that is what happens if they were to lose the neutral or possibly one of the hot legs. Now, if somebody comes along and takes off the neutral, which wouldn't make any sense, obviously you would stand the chance of overamping everything else. So you could possibly create a circuit from the one hot leg completely through the loop to the other hot leg. Now you might ask yourself, why in the world would we ever come along and just remove a neutral? That's an unlikely scenario. Most likely you would probably see the power utility lose a neutral, maybe a lightning storm, maybe some kind of a surge or something like that. If the power utility loses their neutral, it would do virtually the same thing. Circuit breaker. A device designed to open and close manually at a set or predetermined amount of overcurrent without damaging itself. There's several kinds of breakers. There's adjustable, instantaneous, inverse time. Each of these have different requirements as far as sizing them for the circuit, and we'll talk about those in a later course. Clothes closet. A room intended for the storage of garments. It's not intentionally habitable. I'm not exactly sure how you would accidentally end up living in a closet or sleeping in a closet, but I assume they wouldn't put it in the code book unless it's been an issue at some point. And if you look at the closet on the left, that's probably bigger than my family's first apartment. Communication equipment. Electronic communications equipment responsible for video, audio, and data transmission, as well as the tech support equipment like laptops. It also includes the conductors used only for the equipment operation. So the conductors that you would use to tie the equipment together, even though they don't go to another device for origination, those would still be considered part of the communication equipment. Concealed. Wiring that is not accessible because of the structure or finish of the building. Now this brings butterflies to my stomach every time I look at it. Now look at that plaster and lap board. Took some craftsmanship to make that stuff look great, and it always does look great, but boy, they just don't build it like that anymore. Literally. Have you ever tried to take down plaster and lap board before? Whew. Damage would occur if repair or replacement were needed. Continuous load. A load that's expected to draw maximum current for 3 hours or more. Controller. A device that controls the electric power delivered to electrical equipment in a way that's predetermined. Oftentimes you're going to see a controller that will be outside of the area where it's actually controlling the device or the motor, because oftentimes the area where that device is may be a hazardous location. It may be a basic principle of wanting the on and off and actual control of the unit to be at a lower voltage than what the actual fan or motor or device runs at normally. Maybe we don't want our guy out there pushing a button or turning a switch that has 480 volts behind it. We would want something more manageable at a much smaller amount of power, like in a controller. Device. Components of an electrical installation other than the conductors. Its intent is to carry electric energy. It includes receptacles, switches, breakers, and fuses. All of these are devices. Dwelling unit. Must provide permanent fixed methods of living, sleeping, cooking, and sanitation. It's a single unit that has independent living facilities for one or more people. If there were more, we would call it a multifamily dwelling unit. Here are some examples. Multifamily dwelling unit. A building with all of the same requirements as a single dwelling unit, but has 3 or more dwelling units in it. Apartments are a great example. Effective ground fault path. A path designed to, and intentionally installed to, provide a low impedance path from a ground fault to the supply source in order to make sure the overcurrent device or ground fault detectors are able to remove the power as they're intended to do. What does that mean? What literally is an effective ground? Why do we gotta say effective ground fault path instead of just calling it a ground fault path? A ground fault path is there just because. An effective ground fault path is one that you put there on purpose as part of your electrical system to make sure that a short that happens on the side of my house doesn't just sit there and energize the electrical parts outside. It actually will make it back to my breaker and trip the switch so that it cuts the power. It's one that's put there on purpose. That's the difference. Electric discharge lighting, EDLs. Lighting systems that utilize neon tubing or high-intensity discharge lamps. Equipment. General term used to describe items used in electrical installations like machinery, luminaires, appliances, fittings, and devices. Exposed wiring method. On or attached to the surface or located behind access panels. Generally speaking, this goes back to the term accessible when we talked about at the very beginning of the course. It can be removed without real damage to the structure. Feeder. Conductors between the service equipment or any other power supply and the final branch circuit overcurrent device. Ground. The earth. That's all we're talking about when we ground something, making a solid connection to the earth. So when you run grounding and bonding together, they don't mean the same thing. Bonding is connecting stuff, potential current carrying metal objects together. So they get rid of the potential difference between them and we minimize the risk of arcs and sparks. Ground is then taking the stuff that you've bonded together and connecting them to the earth. Grounded, connected to the earth. Ground fault. An unintentional connection between an ungrounded conductor and the metal parts. This electrically conductive path forms by accident in normally non-conductive scenarios like contacting metal enclosures, non-current carrying conductors like the ground, or metal equipment. Ground fault circuit interrupter, GFCI for short, not to be confused with AFCI that we spoke about earlier. A device intended to protect people by de-energizing the circuit when the current to ground exceeds the value established for a Class A device. Now remember the difference between this and an arc fault. An arc fault is trying to get rid of an arc, which generally is a small enough arc that could not create enough potential that it would make it back to the circuit breaker and trip the breaker, but it would create enough heat that it could start a fire. The GFCI is protecting people because it's checking the current going out and the current coming back to make sure that it's within a certain milliamp range, and if it isn't, it's going to take the device offline. According to UL 943, this happens at 6 milliamps or higher and will not trip at 4 milliamps or lower. The safe trip point is above 4 milliamps. So you're looking at 4 to 6 milliamps. So look at the picture we've got here, which is looking at your typical GFCI installation. Okay, so if you look at the power going out and the power coming back, not all of the power is in that circuit. Some of the power is leaving out through that hand that mysteriously is coming through the back of the slide there. So not all of it's actually making it back to the origination in the circuit. So because some of the power is lost, we're creating an imbalance on that circuit, and that imbalance will create a magnetic field and help trip that Gfci. More on the Gfci. Gfci protection does not protect against line to neutral shocks. So if you became part of that circuit by holding on to the hot and the neutral, and the current went straight through you, you could effectively become a low impedance path to go straight through with minimal work being done, so there may not be enough power loss through you to actually trip that Gfci. The failure rate of a Gfci averages around 12%. The outdoor locations, of course, are going to be higher. You've got more extreme conditions. Those are going to be at a failure rate around 20%. In some high lightning areas, you could be upwards around 50%. So keep in mind, while they're not foolproof, they're constantly getting better in the industry with these. Okay, here's some examples of Gfcis. Some of the things to remember. The failure rate's still close to 12%, even under the best conditions. If a lightning strike occurs, the Gfci most likely will fail while still allowing power into it. So it'll fail in the closed position. A ground wire isn't necessary for the function. So when people correlate a ground and the Gfci, those are two separate portions of the code and two different requirements. A ground is not necessarily required for a regular run-of-the-mill Gfci to work properly. It's looking at the difference between the exiting and returning current. And it won't protect against line to neutral shocks, and it's not meant to. Grounding electrode. A conducting object that's used to make a direct connection and a direct electrical connection to the earth. Some of the examples have been around for a long period of time, nothing really new here. Metal frame of the building, metal underground water pipe, concrete encased electrode, ground ring, grounding rod, and any other electrodes listed for this use. Grounding electrode conductor. A conductor used to connect the system grounded conductor or neutral or the equipment to the grounding electrode or the grounding electrode system. Okay, so your grounding electrode is, say, your ground rod. Your grounding electrode conductor is the wire that connects your ground rod to your box or the rest of your grounding system. Equipment grounding conductor. An intentional path that connects metal parts of the equipment, which normally are not carrying current, together, and the grounded conductor or the grounding electrode conductor. Okay, here's an example. Notice we're in a solar setting here. Another example. The equipment grounding conductor can be any one or a combination of the types listed in 250.118. it must provide an effective ground fault path. This part's new. 250.118 says the equipment grounding conductor run with or enclosing the circuit conductors shall be one or more or a combination of the following. Let's look at these 5 examples. Copper clad, copper or aluminum clad conductors, could be solid or stranded, insulated, covered, or bare, wire or bus bars of any shape. 2. Could be rigid metal conduit. 3. Could be intermediate metal conduit. 4. Could be electrical metallic tubing. And 5. Could be flexible metal conduit as long as it terminates in the listed fittings, has a 20 amp or less overcurrent, its length plus the liquid tight plus the flexible metallic tubing length combined is less than 6 feet, so we don't have much to work with there. And it's used where necessary to stop vibration or provide flexibility, but an equipment grounding conductor shall be necessary. Guest room. An accommodation that combines living, sleeping, sanitary, and storage within a quote-unquote compartment. Guest suite. Very similar to a guest room, but has 2 or more rooms in one compartment with or without doors between them. Hermetic refrigerant motor compressor. Combination of a compressor and a motor that are enclosed in the same housing. Has no external shaft or seals, and the motor is operating in the refrigerant. Okay, here's an example. In sight from also applies to within sight and within sight from. This is mentioned and no specific distance is given. The one piece of equipment has to be 50 feet or less invisible from the other piece of equipment. So notice our example here. And it's got to be in sight from. Doesn't say that it has to be on the same wall. Intersystem bonding termination. A device designed to connect intersystem bonding conductors for communications systems to the grounding electrode system. Kitchen. An area, again with the area, similar to bathroom, with a sink and permanent provisions for cooking. Means that your countertop microwave will not be included as a permanent provision for cooking unless you mount it. Labeled. Materials or equipment that have a label, symbol, or mark by an organization acceptable to the local AHJ. Okay, notice the UL listing here. Damp location. Locations that are protected from weather and not likely to be saturated with water, but obviously could. This includes areas that are only partially protected, like open but covered porches, canopies, or even soffits. Wet location. Locations that are likely to be saturated with water or unprotected from the weather. This also includes locations that are in direct contact with the earth are in concrete slabs or masonry, or, of course, are underground. Boy, that would have to be probably one of the more dangerous pictures I think I've ever seen, where people are still living. Nonlinear load. A load in which the wave shape of the current doesn't follow the wave shape of the voltage. Nonlinear loads occur when the resistance is not a constant and changes during each sine wave of the applied voltage waveform, resulting in a series of positive and negative pulses. Traditional load. For reference as to what we should see, we've got a picture here. Examples of nonlinear loads. Fluorescent lights, electronic ballasts, dimmers, motors with adjustable speed drives, computers, data rooms. Overcurrent. Current that's in excess of the equipment rating caused from a ground fault, a short circuit, or an overload. Surge protective device. Three different types. Type 1, permanently connected and listed for the installation between the utility, transformer, and the service equipment. And notice on the lower left here, we've got that, it almost looks like a ring or a collar before that meter. That's your whole home surge protection device. Type 2, permanently connected surge protected device listed for the installation on the load side of the service disconnecting means. So just a different point of installation. Type 3, surge protective device listed for the installation on branch circuits. One final note on this, you want to make sure that you actually have a ground in the receptacle that these strips are plugged into, because their safety relies on that ground. In the event of a short circuit, it basically shunts to ground to trip that device. Article 200. Now we're getting out of the definitions and into Article 200, which deals with identifying the grounded conductors and terminals. 200.2 B. Continuity of the neutral conductor. Neutral conductor shall not depend on a connection to a metallic enclosure, raceway, or cable armor for its continuity. Here you've got the metal being used to connect the neutral to the neutral terminal through the metal box. Okay, that's not acceptable. .119 Identifying an equipment grounding conductor. If the wire is 6 gauge or smaller, the equipment grounding conductor can be bare, green, or green with a yellow stripe. Article 210. Branch circuits. 210.3 Branch circuit rating. The overcurrent device rating determines the branch circuit rating. 210.4D Grouping of multi-wire circuits. All conductors of a multi-wire branch circuit have to be grouped together in at least one location. This will be done using cable ties or something similar, usually at the point of origin. Here's your before and after. You'll notice on the left that we've got kind of a cluster. However, it's not labeled at all. But if you look on the right, somebody has gone back through, cleaned it up nicely, and labeled it. This should be done while marking the branch circuits in the box. It'll not be necessary if all the wires for the circuit are in a single raceway or if the circuits are tagged. The National Electric Code wants to have number tags. Now remember, we're talking about multi-wire circuits. We're not talking about just a normal circuit. 210.5, identifying branch circuits. 210.5C1b talks about how to identify them with your identifying means. If you have more than one voltage used on the system, the circuits have to be labeled at the panel or the board, and of course they've got to be labeled legibly. If you can't read it, then what good is it? 210.8, Gfci Protection. 210.8, Gfci Protection. Gfci devices required by 210.8a through D must be installed in readily accessible locations. You could venture back to the beginning of the program or break out your NEC to Article 100 and see what readily accessible locations are labeled as. Residentially speaking, this is designed to cover all 15 and 20 amp 125 volt receptacles in the following areas: bathrooms, dwelling unit garages and accessory buildings. Now remember, there's nothing that says that you have to put power out to an accessory building like a shed in the backyard, but if you do, it's got to be GFCI protected. Receptacles installed outside, there are requirements for that. Crawl spaces, unfinished areas of a basement, kitchen countertops, within 6 feet of the outer edge of a sink. Okay, some of that is diminished as well once you get into bathrooms and things like that. A boathouse is another one. Within 6 feet of the outer edge of a bathtub or shower. And laundry areas. Continuing on with 210.8, B deals with other than dwelling units. Got to be in other than dwelling unit bathrooms, kitchens, rooftops, obviously for serviceable means, outdoor areas, within 6 feet of a sink, indoor wet locations, locker rooms with shower facilities, and garages, service bays, or any other similar area. 210.11, branch circuit requirements. 210.11a talks about the number of general lighting and general use receptacle circuits in a dwelling unit. Annex D gives the best examples that we've got. Looking at those examples, measuring the floor area of the structure along the outside wall, find the square footage. Here we've got 75 feet in one direction, 20 feet in the other direction. So we take 75 by 20 and we get 1,500 square feet. You take that number times 3 VA. So we've got 1,500 square feet times 3 VA equals what? 4,500. And there are other optional calculation methods for figuring out the general lighting and use outlets. Those are in 220.82B1 and 220.83A1 for dwelling units. And more specifically, those optional methods deal with existing dwelling units. 220.12, general lighting loads by occupancy. Okay, notice where it says here for dwelling units, for our square feet for volt amps, that's where we're getting this, table 220.12. It tells you 3 VA per square foot. So just in case you were wondering where in the world we come up with the 3 VA per square foot. Annex D, again, going into D1A, figure the voltage that your circuits will have, normally 120 volts, and figure that in to find out how many circuits you can get out of it. So we figured 4,500 VA divided by 120 volts equals 38 amps. So your options here are to have 2 20 amp circuits or 3 15 amp circuits. There are quite a few other factors that go into this calculation. There's a derating factor over 3000 VA, like you'll see in table 220.42. Here's an example of some of the derating factors that we're talking about here. Derating factor for dwelling units calculated by multiplying the following percentages for the corresponding amounts of VA that has been calculated. Okay, for the first 3000 VA, we take it at 100%, so it'll be 3000 VA. You will then, at 3001 up to 120,000 VA, multiply by 35%. So it'll be the first 3000 plus whatever your second calculation here comes out to be. There are standard amounts of VA that are added to this calculation based on the circuit as well. They are the small appliance circuits, which are 1500 VA each, the laundry circuit, which is 1500 VA, the electric dryer, which is 5000 VA, or the nameplate rating. You take the largest one for that calculation. If you've got 4 or more fastened in place appliances, excluding dryers, ranges, space heating, and AC equipment, derated to 75% of the load. Here's your example of your calculation in example D1A for family dwelling units. And there are multiple examples that deal with different scenarios in your Annex D location. (210.11b). Make sure you space things out evenly, as it deals with evenly proportioned loads. You must make sure after your loads are calculated that they're evenly balanced from one branch circuit to another, and the wiring is calculated properly for the expected load. 210.11 talks about branch circuits that are going to be required. 210.11c deals specifically with dwelling units. C1, 2 or more 20 amp 120 volt small appliance circuits to cover the outlets in the kitchen, the dining room, the breakfast room, the pantry, and small dining areas. Now, just on a side note, when we did our D1 calculation just a second ago, and we were trying to decide whether we were going to use 2 20 amp circuits or 3 15 amp circuits, most commonly you're going to go with the 20 amp circuits because that's what most of the requirements revolve around. C2 deals with 20 amp 120 volt circuits required for the laundry outlets. Those are required by 210.52F as well. You aren't allowed to add a receptacle or an outlet that's not in the laundry area to the laundry area. Just remember. So if you've got an adjoining wall with a bedroom, you're not allowed to sneak off the receptacles that are in the laundry room to bring it through the wall to the other side to that bedroom. .11 branch circuits required continued on with C, and again we're talking with C dealing with the laundry outlets in C2 and 210.52F. This receptacle is still going to be required. You got to remember your requirement specifically says in C2 that 120 amp 120 volt circuit is required for the laundry outlets required by 210.52. So the receptacle is still required even if the appliance being used will use another receptacle due to different power requirements. And the example would be a stackable washer dryer combo could use a 30 amp 240 volt receptacle and not use that receptacle at all. 210.11 still in the branch circuits required. We're moving on to C3, which deals with bathrooms, and one 20 amp 120 volt receptacle required for the bathroom receptacles. The outlets that aren't in the bathroom aren't allowed on the bathroom circuit, plain as day. You can supply all the outlets in a single bathroom if you'd like, okay, on a single 120 volt 20 amp bathroom circuit. Okay, these can include the lights as well, as long as no single load more than 10 amps. And you can reference 210.23A1 and 2 for that particular requirement. And what you'll find there, 210.23A1 says cord and plug equipment not fastened in place is allowed to draw 80% of the load. And 210.23A2 says cord and plug equipment fastened in place is allowed to draw 50% of the load. Here's your arc fault breaker. 210.12 is going to get into Afci protection, and when it comes to Afci protection, we're in an area where not everything's going to be on the receptacle end of things. This is, your new wave arc fault breaker, where both the line and neutral go into the breaker, and the neutral connects back to the box on the neutral side. And primarily what you're looking for here is a characteristic of an arc fault. All 15 and 20 amp 120 volt branch circuits that supply outlets or devices in these locations require arc fault protection. What locations? Bedrooms, closets, dens, dining rooms, family rooms, hallways, kitchens, laundry areas, libraries, living rooms, parlors, rec rooms, sunrooms, and any other similar areas. So notice we got arc fault protection requirements actually in the kitchens and dining rooms in a lot of the same places that we have Gfci protection. There is a potential in which you'll have arc fault and Gfci protection required in overlapping scenarios. 210.12a does have some exceptions. Okay, one of the exceptions deals with fire alarms. Okay, and the short and sweet of it is, if the smoke alarm or the fire alarm is not controlled by the panel, then it doesn't qualify as a fire alarm circuit. So arc fault will be required. If they go to a panel, it will most likely not be required. Again, that's all subject to the authority having jurisdiction and any amendments that may be in your area, but listen to one of the exceptions. One of the exceptions references you over to 760.121, which is power sources for PLFA circuits. And it says in B, dealing with branch circuits, the branch circuit supplying the fire alarm circuit shall supply no other loads. The location of the branch circuit overcurrent protective device shall be permanently identified at the fire alarm control unit. The circuit disconnecting means shall have red identification, shall be accessible only to qualified personnel, and shall be identified as fire alarm circuit. The red identification shall not damage the overcurrent protective devices or obscure the manufacturer's markings. This branch circuit shall not be supplied through ground fault circuit interrupters or arc fault circuit interrupters. And another exception, another area that this exception actually references you to is 760.41b, which deals with non-power limited fire alarm circuits as well, and it says the same, almost identical thing, and that's 760.41b is your other reference point for this exception to the rule. So, like I said, short and sweet. If it goes to a panel, doesn't qualify, or if it goes to a panel, it won't require arc fault or GFCI. But if it doesn't go to a panel, it's probably not going to qualify as a fire alarm circuit either, and it's going to be required to have arc fault protection. 210.12b talks about branch circuit extensions or modifications, more particularly with dwelling units. In areas where branch circuits are modified or replaced or extended, the circuit must be protected by an AFCI circuit breaker or an AFCI receptacle at the first outlet. Now remember, there will be a requirement also in the branch circuit area that says that this circuit's going to have to be grounded at least to that first receptacle. Doesn't have anything to do with the way that the arc fault circuit interrupter works. It has to do with creating an effective ground fault path that goes all the way back to the panel. The exception, if the extension is less than 6 feet when no devices or outlets are added. 210.17 Electric vehicles. An outlet that has been installed for the purpose of charging electric vehicles shall be on a dedicated branch circuit with no other outlets. 210.18 Guest rooms or suites. Guest rooms or suites have to be wired according to the branch circuit requirements for dwelling units. Okay, so as you might guess, staying in hotels, when you look around, there would be a distinct difference between whether or not you're considered a suite or a dwelling unit or a guest room as far as how the wiring is done. For the most part, obviously, you're going to have circuit protection and all that kind of stuff be fairly close in all those applications where habitation is going to take place. However, there are some fairly small nuances between those that would definitely make a big difference in a multi-story hotel. 210.23 Permissible loads. 210.23 says in no case shall the load exceed the branch circuit amp rating. 210.23 goes on in section A that says 15 and 20 amp circuits can supply lights and utilization equipment. A1 says it can go on and include cord and plug as long as they're not fastened in place. It can only pull up to 80% of the circuit amp rating if it's cord and plug not fastened in place. A2 talks about utilization in equipment that is fastened in place, and it can only pull up to 50% of the circuit amp rating. Remember, both of these are indicating that there's something else on that circuit as well. So the 50% and 80% is, if in addition to whatever's pulling that amp draw on the system, you also have potentially a light or something else plugged into that circuit as well. A2C says that 40 and 50 amp circuits can contain cooking appliances that are fastened in place. Okay, so that's a bit of an anomaly. And A2C also says that you can have 50 amp circuits that can supply non-lighting load outlets only as well. So it just breaks the mold of the 15 and 20 amp circuit requirements that we've got here. Goes into a few nuances. So as we head into part 3 that deals with required outlets, just to give you folks that are keeping track a little update, where if you're following along in the code book, you should be in a normal traditional National Electric code book. You should be on page 60. It's not the same in the handbook, but if you're following along in a traditional, it'll be the same. We're going into part 3 dealing with required outlets. 210.50 deals with your general requirements. Requirements for installing outlets shall be done in accordance with 210.52 through 210.64. Small section, lots of stuff in it. 210.50A deals with cord and pendants. Don't overlook the fact that flexible cord and pendant receptacles are still receptacles. They are still allowed to achieve the requirements that may be required, whether residential or commercial, in areas that do require the receptacles. 250.C appliance receptacles. The concept here is very simple. If the receptacle is intended for a specific appliance, like laundry equipment, the example given here, then that receptacle's got to be within 6 feet of the intended appliance. It seems like that's an awful long ways away, because most of the cords, unless you're going to change out the cords or buy a longer whip or something, are not going to extend 6 feet, but nonetheless, that is the rule. 210.52, dwelling unit receptacle outlets. 210.52 covers 125 volt, 15 and 20 amp receptacle outlets. The outlets are in addition to those that are part of the luminaire appliance, controlled by a wall switch, like you see in 210.70A1, exception 1, switched receptacles, or those in cabinets or cupboards, so potentially one that would be covered up, such as one that you would plug a hanging microwave into, or those located 5.5 feet off the floor. Remember, it's in addition to those receptacles. 210.52 deals with the switching of receptacles, and I wanted to take just a second and just point out the fact your wall placing on your receptacle requirements requires your basic, in a dwelling unit, 6 foot, 12 foot rule. So you should be able to go to any point along the wall, and within 6 feet of that point, one direction or the other, you can reach a receptacle. That requirement does not say that you have to use a duplex receptacle like the one pictured here. What the requirement says is you have to have a receptacle. The advantage that you get with a duplex receptacle is in the event that you need to achieve a lighting requirement as well as a wall spacing receptacle requirement, you could meet both with one duplex receptacle by separating the top and bottom receptacle. And then you could achieve your lighting requirements at 210/70A1 and then the receptacle requirements at 210/52A1. 210/52, getting into the heart of it. A, general requirements for a dwelling unit. A1 deals with spacing. The requirement for a receptacle to be installed in every kitchen, family room, dining room, living room, bedroom, etc. says that no point along the floor line of any wall space should be farther than 6 feet from a receptacle. That's why we slang term call it the 6-foot, 12-foot rule. The rule says no further than 6 feet in one direction or the other from a receptacle, or to get to a receptacle, when in reality if you went dead smack in the middle of two receptacles that were right on the money, 6 feet both directions, it would be 12 feet between the two. 210/52A2 deals with wall space. Wall space in the dwelling units shall include 1. Any space that's 2 feet or more and unbroken along the floor line by doors or similar openings, fireplaces, and fixed cabinets. This includes spaces around corners. You can't go catty corner for your spacing requirement. 2. Fixed panels on interior walls. Large glass panels like those found in the sliding doors that don't actually slide. Now, when you've got sliding doors, generally you've got one panel that slides and one panel that doesn't. 3. Fixed room dividers such as railings. Now, one thing that throws a wrench and oftentimes a homeowner into a tailspin is the requirement at 210/52A2-3. Fixed room dividers such as railings, because this also can refer to banisters at the top of a long stairway or along a lofted walkway in a vaulted room. You've got banisters along those edges so that somebody can overlook, say, the living room from a vaulted area. That could be considered wall space, and you would have to have a receptacle in that area. Now, obviously, if you've got the nice spindled banister along that walkway, you're not going to put the receptacle in that banister. What you're going to do is you're going to probably put it in the floor. And they do make nice alternatives for the floor mounted receptacles. So, here is an example of your requirement. This is the 6-foot, 12-foot rule. Any point on the wall should be no further than 6 feet from the nearest receptacle. So if you're in the middle, dead smack in the middle between two receptacles, it could be 12 feet total. So notice, even the small little 2-foot space in the middle center requires its own receptacle because of the requirement. (210/52A3) is a part I wanted to point out. I just talked about that. If you've got a vaulted area or a walkway that has a banister and no wall on the other side, say you've got a banister on both sides, your receptacle is still something that you're going to have in those areas. So you have to keep that in mind, and you may have to put a floor receptacle in there in order to comply. Floor receptacles can be counted as your required receptacles, but only if they're installed within 18 inches of the wall. Hey, here's another example. Imagine having this beautiful hardwood and still having to put a floor receptacle in there. Again, they make good alternatives for it, so you'll have to plan ahead and make sure that the homeowner is aware of this requirement. (21052)A4, countertop receptacles. Dwelling unit receptacles versus countertop receptacles is a little bit different. Countertop receptacles are installed according to 21052C, and countertop requirements cannot be used to achieve the requirements of the general dwelling units in 21052A. Now, what does that mean? In looking at this picture, what this means is you're not allowed to use your receptacle on that countertop to achieve your receptacle requirements along the wall spacing there on the floor. So you may end up with a couple receptacles that are extremely close to each other. (21052) dealing with dwelling unit receptacle outlet requirements. This is Section B, small appliance circuits. 21052B1 dealing with small appliance circuits says the 20 amp 120 volt small appliance circuits covered in 21011C1 and their requirements found in 21052A and C are meant to extend to kitchens, breakfast rooms, pantries, and dining rooms. Okay, now remember, we had the option clear back when we were talking about the annex and the calculations for a dwelling unit to split, after we calculated the VA that we needed and divided by 120 volts, we were allowed to do two 20 amp receptacles or three 15 amp receptacle circuits in those areas. And although three circuits sounded better, most of these requirements are all 20 amp circuit requirements, like the small appliance circuit requirement. 21052B1, exception number 2. Refrigerators are allowed to be on a dedicated branch circuit as long as it's rated 15 amps or more. So you can have it on its own circuit. It doesn't have to be on the small appliance circuit. The one anomaly is you're not allowed to extend that refrigerator plug, refrigerator's flexible cord up over the top of the countertop to a plug-in that's up there. It would have to be something that's not in a fixed position like that, above the countertop. 21052B3, kitchen receptacle requirements. Here we have a nice wide open kitchen. You have to have at least two small appliance circuits in the kitchen. They can also supply the pantry, breakfast room, dining room, all of the other requirements in 21052B1, but it cannot supply another kitchen. (21052C1), talking about wall countertop spacing. Each countertop space shall have a receptacle. At no point on the wall space should the receptacle be more than 24 inches away in one direction or the other horizontally from that area. So what are we talking about there? Well, in a dwelling unit living room, it was a 6-foot, 12-foot rule. Here we're talking a 2-foot, 4-foot rule. So at no point should you be able to touch a countertop space and be more than 2 feet in one direction or another from a receptacle. Okay, so if you were smack dab in the middle, you effectively could be 4 feet between the receptacles itself. Okay, there are exceptions. Normally, they're not going to be required behind a sink or a range. In addition, they're not supposed to be more than 20 inches off the top of the countertop, and you'll find this at 21052C5. Exemptions. We talked about this just a second ago. Normally you're not going to find it's required around the back of a sink. Okay? However, if there's more than 18 inches behind that sink, that requirement will be there. The illustration in the NEC clearly shows if you've got less than 12 inches behind the sink or the range, less than 18 inches if it's a corner, then no receptacle is required. If you got more than 18 inches, you're certainly going to have that requirement extend behind that corner there on the picture on the right. This is the actual picture out of the NEC that is given for your example. The illustration fairly clearly shows that if you've got less than 12 inches behind a sink or range, 18 if it's in a corner, then you don't have to have a receptacle. 21052C2, island countertop spaces. Each island space has to have at least one receptacle. The requirement is one receptacle. Island dimensions necessary to meet this requirement are a minimum 24 inches long and 24 inches wide. That's your minimum requirement. If that was all one island countertop, nothing on there, the requirement's one receptacle. Some municipalities have that extended out to mean that you have to have two receptacles, but the requirement in the NEC is one. 21052C3, peninsular countertop spaces, are very similar. Each peninsular space has to have at least one receptacle, same as the island. The dimensions are exactly the same, but you have to remember that the peninsular starts at the connecting edge of the counter, not at the wall. So your minimum diameter, or your minimum length from the countertop to the end of the peninsular is 24 inches long, and the minimum width 24 inches wide to that connecting edge. Now it is possible that in that area you may not have any place to put a receptacle. Maybe not on the end, maybe not in the countertop. There are scenarios where that comes up. You will notice almost dead center here that you've got a flip down door with a receptacle inside of that space, and that, believe it or not, is not just something that somebody came up with on a whim. That's a designed product for that purpose. It's for your upper end custom style kitchens that don't want the visibility of that additional receptacle because they don't use it all the time. So they only have it exposed while it's being used. Some municipalities will have some different requirements there. So for instance, one municipality will not allow you to have that kind of installation unless there's a way to only activate that plug when the lid is slid back into a position that the lid cannot be closed on the plug that goes into it. We have all kinds of new devices that are allowing us to be a little bit more upscale, make things look a little bit nicer, and still comply with code. These are some in-countertop style receptacles, and these are UL listed and approved for the wet purpose. 21052C4, separate countertop spaces. Traditional kitchens oftentimes are going to have appliances that are spaced out so that they make sense to actually use. They're not going to be all grouped together. They're not going to be installed to make it so it's easier to comply with code. They're going to be spaced so that they make sense. Usually, this will create little separations in the countertop, oftentimes, say, between the range and the stove, maybe a little, like almost a little part of countertop that just kind of stands out by itself. These are going to have receptacles. 21052C4 deals with these separate countertop spaces. If you have countertops that have areas separated by a sink, range, refrigerator, or another similar appliance, the space has to comply with 21052C1. Okay, so you'll notice here if you've got a space that's 12 inches or wider, like the far right there, between that range and maybe there's a refrigerator on the right hand side of that arrow? Well, it's broken up the countertop into a 12-inch space. That 12-inch space will now have to have its own countertop receptacle, and then the receptacle requirements on the left hand side of that range is going to start from there, and you'll have to have another receptacle within 2 feet from that range. And again, here's another great example. If you have countertops, you have areas separated by a sink, range, refrigerator, or other similar appliance, it has to comply with 210.52C1. Again, if there's less than 12 inches behind the sink, you don't have to have a receptacle. The requirement says if there's more than 12 inches behind that sink, you will have to have a receptacle behind there. More with this 210.52C4. Peninsulas and islands are no different. If you have a peninsular space or an island space, and you've got more than 12 inches separating the closest edge of that sink to the other edge of the, or the larger edge of the countertop of the peninsular or island, like you see in the left-hand example here with a sink, more than 12 inches, it's not considered a broken space. So the requirement is only one receptacle in that entire space. It doesn't matter if that island is 20 feet long. It's still going to be considered one space. If you have the space separated by a range or some other appliance that creates a space that is less than 12 inches from the back of it to the edge of the countertop, such as the example in the right-hand side here, then that will be considered two separate spaces and will require one receptacle in each of those spaces. We're still referring to countertops here, but we're talking about 210.52C5 with outlet locations. Receptacles shall be located on, above, but no more than 20 inches above, in, as long as listed for it, or below, but not more than 12 inches, and only if the counter overhangs less than 6 inches for the countertop. Those are your requirements. There are exceptions. Okay, you've got an exception here. Exception 2, if the island or peninsula is completely flat with no backsplashes or dividers and no means to mount a receptacle 20 inches above the countertop, like cabinets, then there is no receptacle requirement. That is a valuable place to start when you're looking for ways to comply with the code in the peninsular or the island compliance area, because there are absolutely some areas where you're not going to be able to install that. Now, if you're thinking about it, some guys are really wrapping their heads around that, thinking, now how would there ever be a scenario where I absolutely could not put a receptacle in there? Well, what if you didn't have any overhang at all on that peninsular or island, and there was drawers out both sides that slid right up to the edge of the wood, so that you could not mount a receptacle in there because it would slide into, it would be slid into by the doors and such. There are some scenarios that this will really help you out. It's not there as a get out of jail free card, but it's there to aid you in compliance in areas that you absolutely could not follow the traditional rules. 210.52C5 deals with receptacle outlet locations and appliance garages. If you have an appliance garage, it can't be used to meet your spacing requirements for the countertop receptacles. However, your receptacles for the countertop small appliance circuit can extend right on inside of the appliance garage. So you can have it in there, but it can't be used to meet your receptacle requirements. So your 2-foot rule would start on either side of that appliance garage and head out along the wall space, and you'd have to have a receptacle within 2 feet there. 210.52D, bathroom requirements. Okay, we've talked about earlier that there are receptacle requirements and GFCI requirements and such around sinks. And we talked about sinks just in general having a 6-foot rule. If you're around a sink, you're going to have GFCI protection within 6 feet around that in a radial spherical style around. But in a bathroom, your receptacle requirements say you must have a receptacle. 15-20 amp, of course, is a requirement here, as most of them are, within 3 feet of the outside edge of each basin or sink. So we're talking a 3-foot radius. Okay, and that's a perimeter, all directions, any of these areas. Could be on the outer side of the cabinet, could be in front of the cabinet, but new requirements allow no further than 12 inches below the front edge of the sink, and it can be in the sink or in between the sinks on the countertop area. (21052E) deals with outdoor requirements. Receptacles need to be in these areas outdoors in these locations in a 1 and 2 family dwelling. One receptacle in the front and back of the dwelling at grade level. It shall be readily accessible and no more than 6.5 feet above grade. Two, multifamily dwellings. You only have to have your receptacle outside in the front and back at a multifamily dwelling on the dwelling units that are at grade level, and that's it. Three, on balconies, decks, and porches. Only required when attached to the dwelling and accessible from inside. So right outside your back sliding door, for instance. You shall have a receptacle that's no more than 6.5 feet above and accessible from the balcony, deck, or porch walking surface. 21052F gets into laundry areas. In dwelling units, you have to have at least one receptacle, 15 amp or 20 amp, 120 volt, in the designated area where the laundry equipment is intended to be installed, even if it's not being used. And one example that was given recently is, what if I've got a new construction home and the person that's paid for the home, that's buying the home, going to move into the home, has a stackable washer and dryer. So they would never use a 120 volt 15-20 amp circuit. They would only use the elevated, probably 30 amp 230 volt circuit. So what would you do then? The requirement's there even if it's not being used. And notice it talks about laundry area, not laundry room. Exception 1. It shall not be required in a single dwelling of a multifamily dwelling unit that has laundry facilities provided for use by all building occupants. Okay, so if you've got one dwelling of a multifamily dwelling unit that has laundry facilities already for everybody, you don't have to abide by this rule. You don't have to have the laundry circuit inside of the single dwelling in this instance. 21052G, basements, garages, and accessory buildings. In a single-family dwelling, at least one receptacle outlet shall be in these areas required by 21052G1 through 3. These, of course, are in addition to any that might be required for specific reasons dealing with potentially specific equipment. Garages. If a detached or attached garage, notice the key word there, if, has electrical power supplied, you have to have one receptacle in each car space, minimally. So as you can see here in this garage, we don't have a requirement. We've got one receptacle dead center in the middle and no receptacle in each space. Accessory buildings, which is 21052G2. Accessory buildings have to have at least one outlet receptacle in each accessory building that has electrical power supplied. Nothing says you have to supply power to this fancy little shed with an open and with an inward door and an outward door on the other side. A little bit more fancy than what I've got, but nothing says you have to supply power to this. But if you do, one, it's going to have to be Gfci protected, and two, it's going to have at least one outlet receptacle. Basements. You have to have a receptacle outlet in each unfinished area of the basement. In speaking with several code officials and looking at this picture, this is all considered one unfinished area until they start extending the wall out and separating the space a little bit more. So in this area, your requirement is one. Remember, if you have a finished basement, the outlet requirements of 21052 are enforceable depending on how the basement's finished. If you've got a secondary living space or kitchen or bathroom, those requirements may all revert back to 21052 A through C, which deal with your countertop space and your wall spacing requirements and all of that. (21052H) hallways. If a hallway is at least 10 feet long, the requirement says you have to have one receptacle, at least one receptacle. If the measurement is made along the center line without passing through the doorway, that is. Okay, so your measurement in the hallway is 10 feet as long as you're not passing through the doorway. So if you have a 40-foot bath or a 40-foot hallway, the requirement doesn't say you have to have at least 4 receptacles, one every 10 feet. The requirement says if it's at least 10 feet, you have to have at least one receptacle. 21060. Guest rooms, suites, and dorms. 21060A. General requirements. In these areas usually found in hotels and sleeping rooms and dorms, the minimal requirements are those of 21052A and D. Okay, so your 21052A and D are still at play here. If there are also permanent provisions for cooking, they'll have to comply with all of 210.52. So the difference is whether or not we're talking permanent provisions for cooking. Oftentimes you're going to see a countertop microwave be all that you have. But if that microwave leaves the countertop and is now mounted up above the counter, or you have a cooktop or something like that, we could have a permanent provision for cooking and become the same as a dwelling unit as far as requirements go. 21060B, receptacle placement. Hey, this is kind of interesting. The quantity of receptacles must be the same as the requirements in a normal dwelling unit, but the spacing requirements may be altered to fit the placement of the furniture. So that is different. And now we go back to the old mentality of usable wall space, which hasn't really been in the code book since the 50s. If you have a couch there, by nowadays standards, I wouldn't consider that usable wall space, but it doesn't exempt you in a normal house from using that space for a receptacle, because you still have to meet your receptacle requirements. Here we're saying when we get into guest rooms and suites and dorms that the requirements can be altered to fit the placement of the furniture, and usually that's going to be because you have such a small living area. If the receptacle's behind the bed, this is another example given in the code book. It has to be in a way that prevents the attachment plug from touching the bed, or it must be guarded. At least 2 receptacles shall be readily accessible. And you also have all the same requirements for Gfci that you'll find in later chapters. Article 300, General Requirements for Wiring Methods. 300.1 deals with wiring installations in Part A and integral parts of the equipment in Part B. Okay, 300.1a, this article covers all general wiring methods for all installations unless modified in other chapters. Could be modified in chapters 5, 6, and 7, or even in 8. And B, integral parts of the equipment. This article does not apply to conductors that are integral parts of accepted or listed equipment. These are conductors that are placed there by the manufacturer during the manufacturing process of the equipment. 300.2 Limitations. 300.2a Voltages. Wiring methods in Chapter 3 are designed for voltages that are up to but not higher than 1000 volts unless specifically permitted or allowed elsewhere in the code. 300.2b Temperatures. Temperature limitations of the conductors are in accordance with 310.15a3. Now, 310.15a3 is called Temperature Limitations of Conductors. It references tables that you look up with the allowable ampacities and temp limitations, and their derating tables for elevated temperatures, similar to what you would use for 310.15b2a and b. 300.3 Conductors. 300.3a Single Conductors. Single conductors as specified in 310.104a have to be installed within a recognized wiring method. So in looking at what we've got here, we got some knob and tube. And while this may be an existing building, now look at the size of the wood, true sizes of wood. You don't see that anymore. And it may actually still be used. It's there under the existing building exemption. It's not posing a danger or a threat, and it hasn't been upgraded because the building probably hasn't been modified to make it be upgraded. However, you wouldn't see this put back in a new building because it's no longer a recognized wiring method. They want all of the conductors for a circuit to be run together within the same wiring method. Conductors. In 300.3b, same circuit conductors. There are some exemptions to this rule, but generally, all conductors of the same circuit, including grounding and bonding conductors, shall be grouped in the same wiring method. Some of the exceptions are found in 300.3b1 through 4. .4 Protection against physical damage. If the wires are going to be subject to damage, obviously you should be protecting them. Okay, some of the ways that you would protect them. A strike plate. Strike plates are neat, they're handy, and if you try to screw into them or nail into them, they're going to definitely let you know it ain't going to go in there. Okay, on wood, if it's been notched or bored and the hole leaves less than 1/4 inch in front of the stud, you have to use a strike plate. It also applies if it's likely that a nail or a screw can penetrate it. Okay, that's 300.4b2. You could use a bushing. If you've got non-metallic cable going through steel framing, now we use all kinds of steel studs now. It's got to be protected with a bushing. Support. If cables or raceways are supported to framing or furring strips, it has to be supported. Okay, there is really no specific method as to the intervals of the support, so that's going to be up to your AHJ, possibly depending on the scenario, could be up to more than one authority there. It can't be closer to the front edge of the wall than a 1/4 inch, or it has to be protected from nails and screws. If it's above a drop ceiling, the non-metallic cable still has to be supported. It's not allowed to be laid on those ceiling tiles, according to its applicable article in 300.4C. 300.4G, insulated fittings. If the wire is larger than 4 gauge, the wiring method that goes into the box, cabinet, or enclosure has to terminate with an insulated fitting. Okay, some of these are just little nuances that are in the code that are there for specific purposes, usually pertaining to heat buildup, fire, or general contact with the wire through the sheathing if it gets rubbed or bare. 300.6 deals with corrosion and protection against it. 300.6A3, concrete or direct concrete burial with the earth. Ferrous metal raceways or boxes can be in contact with or even in concrete as long as it's either listed for the application, okay, that should go without saying, or if it's not listed, protected against corrosion. Some of the examples would be EMT, galvanized EMT. It requires corrosion protection. Rigid metal conduit, though, if it's galvanized, does not normally require anything additional as far as protection goes. 300.7, raceways exposed to different temperatures. 300.7b, expansion fittings. Raceways shall be permitted with expansion fittings if thermal expansion is a possibility. Hey, if you've got long runs and high temperature swings, usually we're talking 100-degree temperature swing. Hey, for instance, in the Midwest, it is completely likely that you could get down below 0 in the wintertime, yet also above 100 degrees in the summertime. So you've got that 100-degree temperature swing there. Metal, plastic, and everything in between expands and contracts with that high amount of temperature change. So having expansion fittings is very valuable in this scenario. 352.44 deals with PVC expansion, and of course it's given as the next example. Okay, right here. If you've got a temperature change of 100 degrees, we're talking bottom center of this chart, then the length of change for this PVC conduit is how far? 4 inches for every 100 feet. So if you got a temperature swing of 100 degrees, like most places in the Midwest, then you very easily could have a 4-inch gain or lag in that PVC conduit. 300.10, electrical continuity of metal raceways and enclosures. If you have to form an effective ground fault path between all raceways, cables, and enclosures to make sure the circuit's overcurrent device will work in the event of a fault, then of course you're going to have to consult the NEC to do so. An effective ground fault path is one that's installed on purpose, as we discussed earlier, to provide electrical continuity from the equipment or the appliance all the way back to the panel. Hey, this is different from a regular, just run-of-the-mill ground fault path. A ground fault path is generally going to be any method that can take a electrical current to earth, to the ground. Now here we're talking about an effective ground fault path, which is one that's put there by you on purpose to take that electrical continuity back to the panel so that we can aid in the tripping of the breaker, popping of the fuse, whatever the case may be. 300.12, mechanical continuity. Raceways shall be mechanically continuous between the fittings and the enclosure, box, or panel. Why is that? Well, if they're not electrically continuous and you've got a little gap in there and you start to run electrical current on the outside of that fitting or the raceway, then knuckleheaded me comes along and touches one side and then the other side or bumps into it, I could bridge the gap there and that current could run through me to the other side where there's also metal conduit. So I could become part of that circuit. 300.13 deals with conductors and mechanical and electrical continuity. 300.13a, general. No splices or taps inside of the conduit. Should go without saying. You can't service them. You can't see when there's an issue either. 300.14, the length of free conductors at outlets, junctions, and switch points. Well, we're always asking, okay, how much conductors, how much of the free conductor are we supposed to be pulling when we're wiring up our switches or our receptacles or any of those things? It gives us the answer right here, 300.14. You have to have at least 6 inches from the point it leaves the conductor, or I'm sorry, from the point it leaves the conduit or the connector at the box. 300.20, induced current in ferrous metal enclosures or raceways. Alternating current circuits in order to minimize the possibility of induction. Remember, induction is the creation of current using the magnetic field of the wires. Okay, we want to minimize current on the actual metal enclosures, of course, especially if they're ferrous, which is magnetic. Minimizing the possibility of induction on box and metal conduit, etc., you must group all the conductors together. Grouping them all together makes them have opposing magnetic fields. It doesn't cancel each other out like some people say in slang. What it does is it cancels the effects so that you don't have, or at least you minimize, the risk of those magnetic fields on that ferrous metal. 300.22b, wiring in ductwork. Ducts that carry heating and cooling ventilation are only allowed to have wiring methods in or through them if it's necessary to make the equipment operate properly, or accessory or equipment. So sometimes there's accessories that are mounted inside the ductwork that could necessitate wiring, or if the product is listed for the installation and the AHJ allows the installation. 300.22c is an exception. It allows passing through joists or studs that are used for environmental air. Now, oftentimes we'll see thermal pan or some kind of metal that's placed on the studs or the joists that allows us to use return air for part of the ductwork in the mechanical system. 300.22c allows you to have wires that will pass through those areas. One thing that's kind of an anomaly, maybe a little bit of a sidebar, if you're utilizing combustion air drawn through the attic from the soffits into the mechanical room, some inspectors will view that attic as now being part of the ducted system and will not be happy with you in that instance in using the attic with open wiring, can lights, things like that, and will possibly make you meet even stricter requirements than you normally would for your wiring methods in that attic. So think twice about how you bring combustion air into a mechanical room. My suggestion would be to mechanically duct it. 310.15, ampacities. Okay, here is wires up to 2,000 volts. Okay, your different ampacity ratings. Now notice this is table 310.15 B16, probably one of the more common tables that you'll use for wire sizing in the code book. Obviously, there's no derating or anything like that on this particular chart, but you've got your ampacities on both sides, and that's to make it convenient so that you can see copper on the one side easily without tracing it around, and aluminum or copper clad on the other side. (31015B) sizing tables. You'll find sizing tables at 31015B16 through 19, and some of the factors that you'll be considering here are ambient temperature, overcurrent protection, compliance with product listings, and any other safety related influences. Again, this is just an example of table 31015B16 that would be used for sizing, but of course there's 31015B16, 17, 18, and 19, which fit of course different applications. Chapter 4 is titled Equipment for General Use. Article 400, Flexible Cords and Flexible Cables. 400.1, the scope, the overview of this very chapter, says that it covers general requirements for flexible cords and cables in construction and otherwise. Okay, that's a pretty broad statement for and otherwise. The suitability at 400.3. Cords have to be suitable for the environment they're in. This includes the fact that they may possibly have to be guarded, supported, watertight, or corrosion resistant. 400.5. Ampacity of flexible cords and flexible cables. Tables 400.5A1 and 400.5A2 have the conductor ampacity in cords and cables with up to 3 current carrying conductors at ambient temperatures of up to 86 degrees Fahrenheit. If the temperatures are supposed to get above 86 degrees Fahrenheit, you're going to need to derate the acceptable ampacities using table 400.5A3. 400.6a, markings. Remember, if a cord's listed for an unusual location, it'll say so in a factory-made marking on the cord. Some of the examples: corrosive locations, wet, sunlight or UV resistant, or high temperature, etc. 400.7 gives us our permitted uses for these flexible cords and cables. 400.7a, pendants, wiring of luminaires or self-contained lighting apparatuses. 3. Portable lamps, signs, or appliances. 4. Connection of interchangeable equipment. And 5. To simply prohibit noise transmission. Convenience. Okay, here are some examples that we've used in the past. Okay, these are used to promote not only the ease of moving these units around, but also it cuts down on vibration and therefore adds safety, as well as it simply cuts down on the attenuation or the noise that would be created. 400.7 B, attachment plugs. When cords are used in accordance with 400.7a, 3, 6, and 8, it shall be energized from an outlet or the cord connector body and have an attachment plug. There are often times when I'll have a guy that'll ask me, Is it possible that I could put in a garage door opener and cut off the plug end and wire it directly? Well, certainly anything is possible, but that's definitely frowned upon because your Article 400 specifically addresses scenarios like that. If it's a flexible cord connector that's supposed to have a plug, it's got to have a plug on the end. Period. 400.8. Uses not permitted. Flexible cords shall not be used this way. Very straightforward. As a sub for fixed wiring of a structure. So it's not supposed to be permanently wired. You're not supposed to run it through holes in walls, ceilings, floors, including drop ceilings. Shouldn't be run through windows or attached to the structure at all unless it's compliant with 368.56, which says that it's going to deal with cords and cables as its primary goal. Concealed by walls, floors, and ceilings. Not supposed to be in raceways or where it's possible that it could be subject to damage. Okay, these are some examples. This is in a drop ceiling. It's just laying on top of the ceiling tile. Somebody lifts that tile off, they're going to take one in the noodle from that little box there. Hey, here we've got one coming out through a window. One guy looked at that and said, is that CSST or flexible gas pipe? No, that's a big old drop cord. 400.83 prohibits this. 400.82 prohibits this. This was actually done at a dear relative of mine's house to wire in their ceiling fan by a local contractor. 400.9 splicing. Flexible cords should be used only in continuous, unspliced, or tapped lengths and in accordance with 400.7a. 14 gauge and larger cord repair shall be permitted. Okay, so for those of you guys that thought that you just had to cut your cords up and toss them away because they're damaged, listen to this. 14 gauge and larger cord repair shall be permitted as long as the installation, outer qualities, and usage characteristics of the original cord are maintained. Now, a lot of that's going to be up to whether or not the inspector feels that it has been maintained. And then also, are you using listed devices to reattach or to repair your cord with? Okay, here's some examples of a cord repair. Okay, we're putting a new end on here. 400.10, pull at joints and terminals. Common sense is going to tell you that you want to make sure that you've got something meant to keep the stress and strain off the flexible cords. Okay, this is going to keep the tension off the cord, but it's also going to keep the tension off of the equipment that is connected to or the parts as well. Okay, here's some examples of some items that are used to cut down on tension. Probably one of the more common ones right here. 406.4, general installation of receptacles. These requirements shall be done in accordance with Part 3 of Article 210, which we addressed earlier in the program. 406.4a, grounding type. Except for what you find in 406d, 15, 20 amp, branch circuit receptacles shall be the grounding type. 406.4b, to be grounded. Okay, that's the actual title of this section. Receptacles as well as cord connectors that have equipment grounding conductor contacts must be connected to an equipment grounding conductor. Very, very explicit in its explanation. Okay, still in 406.4, C, methods of grounding. The equipment grounding conductor of the receptacle and cord connectors shall be connected to the equipment grounding conductor of the circuit that is supplying the receptacle or cord connector. The branch circuit wiring method shall provide an equipment grounding conductor for the receptacle. Very, very important. See what it says there. The branch circuit wiring method shall provide an equipment grounding conductor for the receptacle. Very, very important to remember that in some certain situations. (406.4d) replacements. Replacements must be done in accordance with 406.4d 1 through 6. Arc fault circuit interrupters and ground fault circuit interrupters shall be installed in readily accessible locations. Okay, we're going to look at 1 through 6 here. Grounding type. If there's a grounding means in the receptacle enclosure already, you have to use a grounded receptacle in the replacement. D1 has to be in accordance with 250.130C. (406.4D2) non-grounding type. Where there is currently no grounding conductor in the receptacle enclosure, you must comply with A. Non-grounding receptacles can be replaced with another non-grounded receptacle. Remember, we want to label it. B. Non-grounding receptacles can be replaced with a Gfci receptacle as long as it's marked, words given here in the NEC, no equipment ground. And C. Non-grounding receptacles can be replaced with a grounding type receptacle that is supplied through a Gfci and marked no equipment ground. (406.4D3) ground fault circuit interrupters shall be provided where required elsewhere in this code. Exception: where the enclosure will not physically fit a new Gfci receptacle, you can put in a new version of the existing receptacle where Gfci is already provided, and the receptacle is marked both Gfci protected and no equipment ground. Okay, remember, key words here, where Gfci is already protected on the circuit. 406.4D4 arc fault circuit interrupters. Where AFCI is required, the receptacle shall be one of the following: a listed AFCI receptacle, a receptacle already protected by a listed AFCI receptacle on that circuit, or a receptacle protected by an AFCI breaker. Remember, the replacement of the receptacle has to either be a listed receptacle AFCI, a receptacle that's already protected by the AFCI receptacle that's on that circuit, or it's got to be on a circuit that's protected by an AFCI breaker. 406D4.1 became effective 1/1/2014 according to the National Electric Code on page 282, in case you're interested. Five deals with tamper-resistant receptacles. They must be provided where required by other sections of the code. 406.12 is one of those areas. Tamper-resistant receptacles. Tamper-resistant receptacles shall be installed in accordance with 406.12A through C, and that's a new section in the code book. 406.12 tamper-resistant receptacles. Again, 406.12 tamper-resistant receptacles shall be installed in accordance with 406.12a through C, and my example here is just A, in dwelling units. In all areas specified in 210.52 that have, so remember, this is all of your requirements, your countertop requirements, your dwelling unit requirements in general, living room, everything. All areas specified in 210.52 that have 15 amp and 20 amp 125 volt receptacles, you shall use listed tamper resistant receptacles. Period. Chapter 5. And remember in Chapter 5 that we're starting our special circumstances. However, if when you're in chapters 5, 6, and 7, you don't have any references to some of the things you learned in chapter 4 or any modifications, then all of the first chapters still apply. The purpose for chapters 5, 6, and 7 are to simply go back in and modify the first 4 chapters if it's applicable to fit a certain circumstance or application. Chapter 5, Special Occupancies. Special occupancies are fairly straightforward, and they may be a little bit difficult to comply with, but their basic purpose for the way they want things installed is pretty straightforward. Special occupancies are an area where, because of the environment, proximity to a certain environment or people, or numerous other factors, contribute to the products or the methods by which they're installed, they require special concern. Remember that when we're talking about special occupancies, not all the information derived in the NEC comes solely from the NEC. They know that there are other industry leaders in this area, and they draw from the NFPA Articles 497 and 499. 497 is the recommended practice for the classification of flammable liquids, gases, and vapors, and hazardous locations of electrical installations in a chemical process. 499, NFPA 499, is called recommended practice for the classification of combustible dust and of hazardous locations for electrical installations in chemical process areas. So let's dig into Article 500, hazardous locations, where we're going to talk about areas where fire or explosion hazards could exist because of the flammable gases, vapors, combustible liquids, or combustible dusts, or fibers could occur. 500.1, the scope. Now remember, anytime you see the word scope in these code books, the word scope is indicative of an overview of a chapter. So 500.1 deals with the scope of Article 500. Articles 500 through 504 cover the requirements for electrical and electronic wiring and equipment for all voltages in Class 1, which is flammable or combustible gases, vapors, and liquids, Class 2, ignitable dusts, and Class 3, ignitable but usually not explosive, fibers and fines. So let's look at those individually. And the first thing we're going to look at is Class 1. Flammable or combustible gases, vapors, and liquids. The groups that are covered are groups A, B, C, and D. Group A deals with acetylene, B, hydrogen, C, ether, and D, hydrocarbons or fuels and solvents. Now, keep in mind, as we go through the hazardous locations, there are several different terms that I'll use, and they're fairly easy to keep separated, but it's worth noting at the beginning here that you're going to run into classes, which basically tell the type of the danger, whether it's combustible gases or combustible dust or something like that. And then the groups, which narrows down to the specific type of danger, a very specific type. And then you'll also see divisions. Divisions are basically indicative of how dangerous is it. Is it there all the time? So you've got suspended vapors or dust in the air, so we always have a fire explosion hazard. That would be division 1. Or is it normally contained and usually does not present a danger, but the threat is still there in the case of an accident or a breakdown, like in division 2. So division 1, normally explosive and hazardous. Division 2, normally not in explosive quantities for a class 1 type of scenario. Class 2, ignitable dusts. The groups that you'll see covered here are group E, metal dusts. Usually you're going to see electrically conductive and explosive flakes of metal. Group F, carbon dusts. And group G, flour, starch, grain, combustible plastic, or chemical dust. So in this class of ignitable dusts, you've got division 1 and 2. Division 1, you're going to have normally ignitable quantities that are suspended in the air. Division 2, normally not sufficient suspended quantities to ignite. However, accidents could happen because the dangers obviously still exist. Class 3, fibers and flines. Okay, generally here, the dust that we'd be talking about would fall into the group that best typifies the chemical makeup of the dust. So you may actually have to go into the NFPA articles that we had spoken about earlier, which are NFPA 497 and NFPA 499, to figure out exactly which types of dusts that we're talking about. But the groups that are covered here usually deal with textiles and woodworking. They're easily ignitable, but not likely explosive. And here your division 1 means it's handled or used in manufacturing. Division 2 means it's stored or handled in storage exclusively in manufacturing. So you'll remember your division 2, accidents could happen because the danger is still there, although it's a diminished likelihood that it would happen. So your divisions versus classes. Divisions versus classes. You've got your classes that are going to name the type of danger. Your divisions are going to tell how much danger is present, as we spoke about earlier. Division 1's the most dangerous. Danger is always present. This is going to be your most expensive area to install anything because it's going to have to be the safest devices that are out there. Division 2, it's still dangerous, but the material's normally not in enough quantities to be dangerous. So the danger is still present and could pop up in the accidental situation, whether it's a breakdown or a spillage or something like that, but normally the danger is contained. And it's also usually got a secondary approach to safety, which deals with positive mechanical ventilation to keep the Division 1 components out. And remember, your groups are divided into A through G for the gases and vapors and liquids and dusts and all that kind of stuff, which we just spoke about. They're located specifically in Class 1 and Class 2 when you're talking about A through G. And Class 3 dusts are going to be a little bit more complicated. So that group is going to have your assignment based on the type of chemical dust makeup. And one other thing that's important to review right here is you can install a Division 1 piece of equipment in a Division 2 space, because Division 1 is going to have all of the most strict safety requirements, which makes it most expensive. So those devices are going to be able to be installed in the Division 2 area, even though you probably wouldn't install them in those areas unless specifically asked to by an AHJ. Division 2 locations would generally not be able to, or Division 2 approved items would not be able to be installed in Division 1 area most of the time. We'll look at our first device right here, 500.2. We'll look at a couple of definitions. Dust ignition proof. It keeps dust from getting in and heat, arcs, or sparks from getting out. Pretty simple. Dust ignition proof equipment been enclosed in a way that keeps dust from getting into the inner components and doesn't allow any of the other stuff to get out. So you'll notice there the red label that indicates that it's dust ignition proof, and also will indicate what location or temperature rating that can be installed in as well. Dust tight. Dust tight is constructed so that it'll keep dust out. It's as simple as that. It doesn't have anything to do with arcs and sparks. It just simply is designed to keep dust out. Hermetically sealed. Completely sealed from the atmosphere, usually done by fusion or brazing or welding. In the mechanical side of things, one general way to tell that something is hermetically sealed is that it does not come with any kind of taps on there for you to work on it from the factory. You would have to add those taps. Usually you're going to see equipment that is 5 pounds or less be hermetically sealed on the mechanical side of things. Non-incentive circuits. Big word. Worth talking about. Might spark under normal operating conditions, but it might not release enough energy to cause ignition. However, the circuits may contain enough energy for potential ignition if the equipment and the process fails. So it's not completely foolproof. Non-incentive component. It may spark under normal operating conditions, but it must not release enough energy to cause ignition. The housing of the non-incentive component is not intended to keep out flammable atmospheres for this reason. 500.3 Other articles. Unless modified in Chapter 5, all installation requirements that you find in Chapters 1 through 4 still apply. It's worth continuing to note that. Just because we're not in Chapters 1 through 4 anymore, and we're in the 5 through 7, which is basically there to modify chapters 1 through 4. If it's not mentioned or modified in these chapters, the first 4 chapters still apply. Combustion principles. If we're going to talk about combustion principles and really break it down, we're going to have to talk about what it takes to actually create combustion, okay, which is fairly simple. Some people overcomplicate this and make it really difficult. Some of these fire triangles is what they're called, will have 20 or 30 different layers. Now, in reality, as tradesmen, we know that it takes a certain mixture, fuel to air mixture, in order for combustion to happen properly. Okay, but there are all kind of variances, plus and minus, that the combustion can still happen, but not be complete combustion. It could be dirty combustion. So we're going to look at this very simply, and we're going to say that in order for combustion to occur, we have to have a fuel. We have to have some sort of fuel, right? And our potential fuel types that we're talking about here deal with our classifications of hazardous locations. That's what we're talking about. So we could have combustible fuels, which oftentimes we're talking about natural gas or LP gas, especially if we're talking residentially speaking. But then we could also be talking about grain dust or textile dust. Okay? And those would have to be suspended in the air in sufficient quantities to create a hazard. So in order to have combustion, we also got to have enough air. And I have to have a good fuel to air ratio to support that flame. So if you're going to measure the air, especially in a combustion scenario, you're going to have to know what you're starting with in order to know what you're supposed to end up with. So in the air that we breathe, it's not rocket science. We don't have 100% oxygen in that air. What we have is 78% nitrogen, and under normal everyday circumstances, at what's considered a low temperature heating point below 2000 degrees, nitrogen and oxygen oftentimes will not have any kind of chemical reaction, and so the nitrogen will pass through the combustion process unscathed. We have roughly 21% oxygen, so nowhere near 100% in the air that we breathe. Any combustion that we have is going to diminish that. It's going to use that oxygen up, create chemical reactions and such that are going to make it so it's not pure oxygen that we can use anymore. And then of course 1% is considered other gases, things that are basically non-conducive to the situation. They're null. They have no bearing either way. And then we've got our fuel types. We've got our air. We have to have something to start the fire, right? So we got to have some sort of a heat or ignition source. A heat or ignition source could be as simple as an open flame. Somebody smoking a cigarette or lighting up a match or a lighter. It could be just an incendiary flame that we've got going on. It could be a spark from contacts making in a relay or on a contactor or a motor starter or something like that. Or it could be basically a friction spark, a static spark. And then we also could have pressure. At this point in the game as tradesmen, most of us understand the game that we're playing, and that game involves manipulating pressures and temperatures. If you can manipulate something to the point in which the pressure goes up, when the pressure goes up, the temperature goes up, which allows you to control the combustion process. 500.5a, classification of locations, deals with where everything's going to be put. That's really what it comes down to. Classifications deal with human safety, but also it deals with what products are going to go into those locations to keep that human safety going. And obviously we don't want the building to burn down either, but that goes along with it. Human safety's got to come first. So The main thing is, in order to reduce the expensive equipment and wiring methods that would have to go in Division 1 locations, always know where that brake line is in Division 1, Division 2, so that you can install as much as possible out of the Division 1 location and in the Division 2 or beyond locations. They can communicate, but it would save you a boatload of money and ease of install if you can keep it out of there. 500.5b, Class 1, flammable or combustible gases, vapors, and liquids, which is Class 1. Again, the groups that are covered are groups A through D: acetylene, hydrogen, ether, hydrocarbons, fuels, and solvents, some of the more popular ones that we've heard of, common terms. Remember, in Division 1, in Class 1, we're talking about the flammable or combustible gases. The basic difference there is your flash point. Flammable is going to be below 100 degrees and combustible is going to be over 100 degrees for your flash point. That's all it is. Flammable or combustible gases, vapors, or liquids. Division 1, normally explosive and hazardous. Division 2, normally not in enough quantity to explode. Hazard's still there, normally not in this sufficient quantity. 500.c, Class 2, ignitable dusts. Ignitable dusts cover groups E through G, some of the more common ones. Metal dusts, electrically conductive and usually explosive. Carbon dusts, flour, starch, grain, combustible plastic, things like that for group D. Example here would be, for instance, I know of a tortilla factory, and at least some of the areas there are Division 1 or Division 2 Class C locations. Remember, the divisions for Class 2 deal with the amount of dust that's actually suspended in the air normally. So Division 1 is normally ignitable quantities suspended. So there's enough there and there's a good enough fuel to air ratio that we could have an issue. Division 2, normally not enough suspended quantity for an accident to happen. Could happen, but normally not enough there. And then (505d) Class 3, which are your fibers and flines. Usually when it comes into Class 3, oftentimes the groups that are covered are going to be textiles and woodworking areas, but there's no specific group. You're actually looking for the classification or chemical makeup of the dust in order to tell what the actual ignition qualities are of these. So it's actually a case-by-case basis in the textile and woodworking industry. Remember, here, instead of having gases in the air or dust in the air, now we're looking at where are we doing the textiles and woodworking. Division 1 is when it's being handled or used in manufacturing, and Division 2 is it's being stored or handled in storage exclusively in manufacturing. So still could have the accidents because the danger is still there, but it's more unlikely that you won't. 500.6, looking at the material groups. Again, Class 1 groups out of 500.6a were groups A through D. Okay, some of the examples: acetylene, hydrogen, ether, and propane. Class 2 groups out of 500.6b are basically groups E through G, which include metal dust, electrically conductive and explosive, carbon dust, similar to coal, and flour, starch, grain, and combustible plastics, would be your group D, G. 500.8 Equipment. Article 500 through 504 require special equipment for special circumstances. So safety can be maintained to people and of course to the property as well. 500.8a deals with the suitability of that equipment. Suitability of equipment shall be determined by one of the following. 1, this would be 500.8a1, the listing and labeling. 2, the evidence of compliance by a qualified testing agency. 3, any other evidence acceptable to the AHJ, such as manufacturer testing, or potentially it's a product that you've asked for special installation provisions from the inspector, and he said, okay, if you get a third-party testing agency and they come back with findings that are acceptable to me, I'll let you put it in. Those findings would be something that would be acceptable in this category 3. 500.8b3 hazardous approvals. Where allowed in 501 through 503, you can have general purpose equipment or equipment in general purpose enclosures in Division 2 locations, providing the equipment normally does not constitute a source of ignition. And here's some examples. 500.8c, markings. Unless you see an exemption in 500.8c6, all equipment going into hazardous locations have to be marked to show the environment that they've been tested for, including C1 through 5 here, classes or the class, the division, only if it's for Division 2 only, material classification group, its equipment operating temperature rating of 40 degrees Celsius or higher, or ambient temperature rating if less than negative 25 degrees Celsius or greater than 40 degrees Celsius. Now let's look at a couple of those. C2, where we talked about division and only if it's for Division 2. If the equipment is suitable for Division 1, then you can omit the division label because it's automatically allowed in Division 2. C4, the temperature rating of higher than 40 degrees Celsius. For Class 1 and 2 locations, the temp rating's got to be based on the maximum temp that the equipment could run at. If it were running with the maximum amount of dust it could possibly accumulate. The label shall have the temp ratings from the label, from the table at 500.8c, which uses what's called T codes. And C5, talking about the temperature rating again, markings have to be in Celsius. So you've got to make sure that you've got your positive and negative rated in Celsius on these labels. It's a universal label. .8c example. Okay, here's your example of a label. Okay, notice we've got our classes, divisions, groups. You also have your T codes on the far right with the C next to them for your Celsius label. And then you also see the listing marks on here. That 500.8c classification of maximum surface temps, I thought it would be prudent to go ahead and put this table on here so that you could see what those T codes actually are and what they relate to. So you notice they've got the Celsius marking and the Fahrenheit marking, which you might find on the label. But the Celsius is going to be your mandatory label that you're going to see pretty much on all labels. .8E 1 through 3 deals with threading. Pretty simple concept. Threaded entries into explosion-proof equipment shall be made up with at least 5 threads fully engaged if it's standard threads, or 8 threads fully engaged for metric threads. And all unused openings have to be closed with a listed metal close-up plug. 500.9 specific occupancies. Okay, there are tons of specific occupancies that are dealt with in Article 500. 500.11 deals with garages, repair, and storage. 513 aircraft hangars. 514 gas stations, motor fuel dispensing facilities. 515 bulk storage plants. 516 spray booths, spray applications and coating. 517 healthcare facilities. That's a real major one. If you work in healthcare facilities, you'll want to pay special attention to that. It seems to me, just my own opinion, that anytime you're working in a healthcare facility, you're always going to be following the most safety rules that you could possibly have. 518, assembly facilities, like gyms, auditoriums, conference rooms, and restaurants, all examples given by the NEC. Article 550, mobile homes, manufactured homes, and mobile home parks. 550.1 covers the scope. Article 550 covers the conductors, equipment within or on a mobile and manufactured home, and conductors that connect mobile and manufactured homes to their electrical supply. 550.2 definitions. Got a big one right here. Manufactured home. A structure that is built on a chassis and designed to be used as a dwelling unit with or without a permanent foundation. So some folks decide, in their own head that, hey, that's not a manufactured home if it's got wheels on it. Well, that's not necessarily true. There are other provisions here. I have met people that have a manufactured home on a foundation and still have the wheels downstairs in the basement. So the wheels really have nothing to do with whether or not it's considered to be a manufactured home. Okay, so it could be with or without a permanent foundation. There are other provisions. Like I said, it must be at least 8 feet wide and at least 40 feet long, or at least 320 square feet. Those are all parameters given in the code. However, for the purpose of the article we're talking about here, the term mobile home includes manufactured homes. Okay, and there are lots of different examples that we've got. This one here is beautiful. I would never have guessed that that was a manufactured home. 550.4 general requirements. Hey, remember, when we're speaking about general requirements, these are things that apply throughout this entire section, this whole article, unless they're modified someplace else. So 550.4a, mobile homes not intended as a dwelling unit. Well, what would you be talking about here? Well, probably the most common would be a job site trailer. A mobile home not intended as a dwelling unit isn't required to meet the 100 amp minimum circuit capacity requirements of 550.32c for a dwelling unit. Okay, and you'll see that picture down here below. (550.4b). What happens if a mobile home or a manufactured home is not actually in a mobile home park? Does it have the same compliance requirements? Mobile homes installed in some place other than mobile home parks shall comply with this article. So, pretty straightforward. Article 550.12, branch circuits required. You might be surprised to learn that the requirements in a mobile or manufactured home mirror the traditional homes. So let's look at those real quick. The lighting, same calculation found in Annex D. 3 VA times the square foot of the home divided by the voltage. Right? So that's your lighting calculation. Your small appliance circuit, you got to have 2 or more of those. They got to be 20 amp, 120 volt. You have to have 1 laundry circuit, 20 amp, 120 volt. When it comes to general appliance, if your appliance is cord and plug, normally what we're talking about here, fixed in place with a light or other receptacle on that circuit, you can only pull up to 50% of that circuit's load. Remember, that's the appliance and you've got other things on that circuit. Now, if the appliance is fixed but there is no other receptacles or lighting on that circuit, you can pull up to 80% of the circuit load. And then also, if you've got a cord and plug appliance that's not fixed in place, so you can move it around, you can also pull up to 80% of that load. When it comes to bathrooms, you got to have at least 1 circuit, 20 amp, 120 volt. And again, just like in traditional homes, you can't serve other rooms with that bathroom circuit. Worth remembering. 550.13, receptacle outlets. This section is going to cover types of acceptable outlets and, of course, their installation requirements. So, let's look at them. A, 550.13a, grounding type. All must comply. The receptacles have to be of the grounding type. They have to be installed according to 406.4, and they have to be a 20 amp or 15 amp 120 volt circuit unless it's to a specific appliance, and then it can be slightly different depending on the appliance. So we mentioned 406.4. Let's take a little bit closer look at that. (406.4) General installation of receptacles. Now, these requirements, again, the command in the code is shall be done in accordance with Part 3 of Article 210. But again, we're talking about Section 406.4. So 406.4a talks about grounding type, and it says for what you find, except what you find in 406d, all 15 and 20 amp branch circuit receptacles shall be the grounding type. And 406.4b says that receptacles as well as cord connectors that have equipment grounding contacts must be connected to an equipment grounding conductor. Pretty straightforward. And 406c basically lines out what your methods of groundings are. The equipment grounding conductor of the receptacle and the cord connectors shall, again, that's not a choice, that's a command in the code, be connected to the equipment grounding conductor of the circuit that is supplying the receptacle or cord connector. The branch circuit wiring method shall provide an equipment grounding conductor for that receptacle. Period. That's 4064C, methods of grounding. Not a lot of rocket science, but definitely not a lot of wiggle room. 4064D, replacements. They must be done in accordance with 4064D 1 through 6. Arc fault and ground fault receptacles shall be installed in readily accessible locations. Remember, it doesn't mean that it has to be a receptacle when we're talking about it in the code. Okay, but if we're using receptacles, they have to be in a readily accessible location. So, again, replacements. Grounding type. If there's a grounding means in the receptacle enclosure already, you have to use a grounded receptacle in the replacement. It's as simple as that. 4064D2 talks about non-grounding type. If there's currently no grounding conductor in the receptacle enclosure, you must comply with A, B, and C. And what they say is non-grounding receptacles can be replaced with another non-grounded receptacle. Okay, so that is still okay. Okay, because if there is no ground wire in there to hook up to, and you're not going to be required to run a new one in this particular instance, then you can replace it with what's there. Non-grounding receptacles can be replaced with a Gfci receptacle as long as it's marked no equipment ground. And C, non-grounding receptacles can be replaced with a grounding type receptacle that is supplied through a Gfci and marked, again, exact words in the code, no equipment ground. 4064D3, Gfcis shall be provided where required elsewhere in this code. So what's the exception here? Where the enclosure will not fit, it physically does not allow the girth of a Gfci receptacle. You can put a new version of the existing receptacle where Gfci is already provided and the receptacle is marked both Gfci protected and no equipment ground. Okay, so if you have the Gfci protection and you're replacing a receptacle with a non-Gfci protected receptacle after the fact, you're going to have to label that as well as the no equipment ground. (4064D) 4. Arc fault circuit interrupters. Where AFCI is required, the replacement should be done with one of the following: a listed AFCI receptacle, a receptacle already protected by a listed AFCI receptacle on that circuit, or 3, a receptacle protected by an AFCI breaker. And remember, some folks forget that this was not immediately effective in the code because the arc fault breakers had only newly become available shortly before, and still many of them were in the testing process. So this particular section of the code actually became effective on 1/1/2014 according to the National Electric Code. Now, if you're not believing me, we're talking about the 2014 code, and if you go to page 282, not the handbook, the actual code, it actually will tell you on page 282 this very information. 406.4d 5. Tamper resistant receptacles. They must be provided where required by the other sections of the code. Okay, remember 406.12 is an other section of the code, and it says specifically for tamper resistant receptacles, tamper resistant receptacles shall be installed in accordance with 406.12 A through C. So let's look at those. 406.12 A, dwelling units. In all areas specified in 210.52 that have 15 and 20 amp 125 volt receptacles, you shall use listed tamper resistant receptacles. Okay, not a whole lot of rocket science there. So everything that's in 210.52, whether it's section A is going to be pertaining to a lot of this as far as the headache, but the countertop receptacles, of course, are going to create a headache as well if you're not used to this. But everywhere in a dwelling unit that requires receptacles in 210.52, got to have tamper resistant receptacles. 550.13b, Gfcis. All 15 amp and 20 amp 120 volt receptacles that require Gfcis in a mobile or manufactured home are ones installed outdoors in compartments that are accessible from outside, bathrooms, in luminaires, lighting fixtures, kitchen countertops, or within 6 feet of a sink. 550.13f, receptacles not permitted. Hopefully, according to this picture, you are making the assumption that this one is not permitted. If you were the one that was looking at this trying to figure it out and can't really figure it out, maybe we better go back to the drawing board. 550.13 F1, no receptacles over or in a bathtub or shower. 550.13 G, also speaking about receptacles not required, G2 says in the wall space behind doors it can be opened fully against a wall surface. So remember, we're in Article 550 here. We're not in a traditional home. We're talking about mobile homes. So if a door can be opened completely flat against a wall surface. So the interpretation that I've had from several of the code officials have said, if you have a door that basically has a little button hook opener, you don't have an actual handle on there, and it can open up against a wall completely flat, then they don't want a receptacle back behind that door. It also could be a door that when it opens up, the knob actually opens up into part of a closet opening, which allows the door to completely sit against that wall flat. 550.16, grounding. Grounding of the electrical and non-electrical metal parts in a mobile home shall be through a connection to the grounding bus in the mobile home panel board. The frame of the mobile home nor the frame of any appliance shall not be connected to the grounded circuit conductor of the mobile home. Okay, surprise, surprise, that we have a lot of the same principles at play when it comes to mobile homes. 550.25b, arc fault in mobile and manufactured homes. 15 and 20 amp 120 volt receptacles in these areas require arc fault protection. It's going to surprise you. but it's exactly the same as what a traditional home is. Remember, just because the dwelling unit is a little bit different doesn't mean that we diminish the safety of the dwelling unit. We're still concerned about people and property. 550.32, service equipment. 550.32a, the mobile home disconnect. A disconnecting means must be located adjacent to, here's that within sight from that we talked about in some of the earlier definitions, but not more than 30 feet from the exterior wall of the mobile home. So oftentimes it's going to be out in the yard, but remember, it's got to be adjacent to, in sight from, so we're not talking on the other end of a forest or the other side of a fence or something, but not more than 30 feet from the exterior wall of that mobile home. Okay, when it comes to manufactured homes, they can be located on the outside wall of the structure, just like a traditional home. You have a minimum ampacity of 100 amps, and it has to be 120 240 volt service. So one thing that is, in addition to this, worth noting, that there are height requirements for this as well. And the height requirements come in F. So 550.32F say that the height requirements for the service disconnect cannot be any lower than 2 feet from grade or any higher than 6 feet 7 inches from grade when the disconnect handle is in the highest position. So remember, you have a height requirement, okay, and this goes on the side of the home when it's mounted there for a manufactured home, but also we're talking about mobile homes that traditionally have these service disconnects mounted on a pole or something similar. It's got to be between 2 feet off the ground and 6 feet 7 inches off the ground. Article 590, temporary installations. 590.1 is the scoped Article 590, and it tells us that you're going to find in this article the temporary power and lighting requirements for emergencies, tests, renovations and construction, as well as, surprisingly enough, holidays and special occasions. 590.2, all installations. Okay, when we're talking about all installations, this is your baseline. This will apply to all of your temporary installations unless modified. So 590.2a deals with other articles. All requirements of the National Electric Code apply to temporary installations unless specifically modified in this article. So a lot of people look at temporary installations and think that they can go ahead and throw whatever together works and it'll be good enough. In reality, that's not true at all. All the requirements that are there in the code are still there in the code, even though it's just for a temporary installation. So it's very important to remember that going forward, so that way when you're dealing with this stuff out in the actual field, you're taking life safety into account. 590.2b, approval. Temporary wiring methods are acceptable only if approved based on the conditions of use and any special requirements of the temporary installation. So, when it comes to approval, who do you suppose has the ability to approve and not approve this stuff? Exactly. Your authority having jurisdiction, your inspector. Hopefully all of your installations look just this nice, but chances are not everybody's does. .3 deals with time constraints. So time constraints generally are referring to how long you can have these temporary situations sitting there. And 590.3a talks about that durational period. Temporary electrical power and lighting installations are only permitted during the period of construction, remodeling, maintenance, repair, or demolition of the buildings, structures, equipment, and similar activities. When the construction is done or the temporary scenario has been remedied, so now it's a permanent scenario, all the temporary stuff's got to go away. The approval's over at that point. 590.3b deals with holiday lighting as well. It says you only have 90 days to keep up holiday lights. So for some of you folks that keep your holiday lights all stapled up all year round, in your area, chances are if you've always done it, your inspector's fine with it. However, if you read the code as is, in a very direct approach, you would see that it says very clearly that that's not allowed. And the interpretation also goes a little bit further and says you can't just unplug them. You have to take them down, which is, obviously adds a lot more to the job if you don't just unplug them. 590.3 dealing with time constraints in section D, removal. Temporary installations must be removed immediately when the temporary situation that you were using it for been taken care of. And we see this kind of stuff all the time. Maybe not this particular kind of stuff, but we see temporary installations all the time. Some may be a little bit worse than others. 590.4 General Requirements. Okay, keep in mind that everything in the first 4 chapters of the NEC are going to apply to temporary installations unless they're specifically modified. One of those sections is Gfci. You still have to have ground fault circuit interruption protection and also your protection for personnel in place as well. That still applies even though it's a temporary scenario. 590.4 General Requirements. 590.4c deals with branch circuits. Okay, remember we're talking about temporary power and lighting. So this is dealing with temporary scenarios. All branch circuits still have to originate from an approved power outlet, panel board, or enclosure as well. So for this section, you'll also see that non-metallic cable like Romex should be able to be used with no limitation for height or construction type and doesn't have to be concealed in walls, ceilings, and floors. So if you're wondering why you see your basic non-metallic cable used on job sites for temporary scenarios, it's because its limitations are a lot less than some of the other types of wiring methods that you could use. Okay? And plus, just all around, it's quicker and easier to use. 590.4D1 talks about receptacles. All receptacles shall not be on the same circuit as temporary lighting on a construction site. Shall not is a huge saying there. So what they're telling you is you cannot put receptacles on the same circuit as temporary lighting on this construction site. And they've got to be connected to an equipment grounding conductor so that the overcurrent device, like the breaker, is going to trip properly. And they have to be Gfci protected. So in brief overview on this one little important section here, it tells us that you could Gfci protect the lighting circuit if you wanted to. There's nothing that prohibits you from doing that. However, you're not killing 2 birds with 1 stone, meaning putting the lights and receptacles on the same circuit and Gfci protecting it all so you run less wire. You're not allowed to put this, the receptacles on the same circuit as the lighting. So oftentimes you're seeing folks that will run The lighting separate, of course, and not GFCI protected, while running the receptacles on a GFCI protected circuit, because that's actually required. .590.4F says your lamps have to be protected, right? And that's a shall statement. Lamps shall be protected from accidental damage by contact with the use of a lamp holder with a guard. .590.4G talks about splices. No boxes are required for splices or junctions on a construction site as long as the equipment grounding continuity is maintained. So, we don't have to necessarily follow all the same principles because this is one section that's modified a little bit. We don't have to have the splices inside of a box as long as its ground is maintained and the method that you've used is giving it proper installation and personnel protection, as well as being suitable for the environment that it sits in. .590.4H talks about protection from accidental damage. Cords and cables shall be protected from damage. We're talking about rollover damage as well as sharp corners, vibrations, heat, all that kind of stuff. And there's some pretty ingenious ways that folks do this. Some of these products are really pretty cool. They work well, they're durable, and they also look pleasing on a construction site. They don't make it look all bulky and as much of an eyesore as what you would think. .590.4 general requirements in I. Termination at the devices. When terminating flexible cords and cables in a box, they have to be secured with fittings listed for that purpose. .590.4J. Supporting. Cable assemblies, flexible cords should be supported and spaced appropriately for the location to ensure that there's protection from physical damage. Okay, the support, of course, is going to be determined by your local inspector. There's not a lot of guidelines in the National Electric Code, okay, but there are job site conditions that are outlined in 590.2b. And it's also important to remember that new to the code in 2014, extension cords do not apply to this rule. .590.6 ground fault protection for personnel. All temporary wiring supplied that can be used by personnel, by people, shall have ground fault protection. It doesn't matter whether the power is derived from the power utility or if it's site derived, like solar or gas powered generator. Makes no difference. You still have to have GFCI protection for personnel. .590.6A1 receptacles not part of the permanent wiring. So we'll look at this in a little bit more depth. All 15, 20, and 30 amp 120 volt receptacles used by personnel shall have GFCI protection. Listed cord sets that have integral GFCI protection are allowed. So this is one area that's modified as well, above and beyond what Article 210 talks about. It says that all 15, 20, and 30 amp receptacles. So it used to be 15 and 20 amp in just a general sense for residential dwelling use. Now we're talking about 30 amp as well. .590.6A2 receptacles existing or installed as part of permanent wiring. This portion here may be easier described as permanent receptacles used as temporary power. All 15, 20, and 30 amp 125 volt receptacles that are existing in the structure and may be used even if temporarily for power during construction by personnel shall have Gfci protection. Listed cord sets that have an integral Gfci protection are allowed. Now we're talking 590.6A3 receptacles on 15 kW or less portable generators. Again, 15, 20, and 30 amp 125 volt receptacles on portable generators up to 15 kW in size shall have Gfci protection. Again, listed cord sets that have integral Gfci protection are allowed. Now we'll move on to a completely new section. A completely new section for us in this presentation. It's obviously not new in the code. However, this is a largely expanded section in the 2014 code book. Article 625, Electrical Vehicle Charging Systems. 625.1 deals with the scope, the general overview of this section. This article covers the installation and safety related to the equipment and devices related to electric vehicles. 625.2, definition of an electric vehicle. A vehicle that has a motor primarily powered, not completely powered. Okay, it could be, but it doesn't have to be. It says primarily powered by electricity and is for on-road use. These include automobile, bus, truck, van, neighborhood vehicle, and motorcycles. Right? There's some pretty cool ones out there. The industry's come a long, long ways. (625.5) having things listed or labeled. All electrical materials, devices, fittings, and associated equipment must be listed or labeled for the purpose. Part 2, the equipment's construction. 625.10, electric vehicle coupler. Okay, this is the actual section where we talk about hooking up the electric vehicle for charging purposes via coupling unit to the charging device or the power supply. Electric vehicle charging coupler shall comply with 625.10 A through F, and they are polarization. Coupler must be polarized. B, non-interchangeability. Coupler cannot be configured in a way that allows it to be wired in and used on other electrical systems. It doesn't say that it can't be used on other electric vehicles other than yours, but it says it can't be used on other electric systems. Construction and installation. It shall be made and installed in a way that prohibits inadvertent contact between live parts and people. Unintentional disconnection. It must have measures that prevent accidentally being disconnected. And we're continuing. E is grounding pole. It must have a grounding pole integrally or set up as an isolated system. And the grounding pole requirements say that the grounding pole has to be set up or constructed so that it makes contact to the equipment first and breaks contact first as well. 625.15, more particularly Section B, ventilation not required. Mechanical ventilation is not required for electric vehicle storage batteries or equipment where it has been listed or labeled as suitable for charging electric vehicles indoor without ventilation. The equipment has to be marked, clearly marked, stating ventilation not required on the device. It shall be visible even after installation, and that's a code requirement. Okay, primarily what we're looking at here is, there are some batteries that while being charged, they put an off gas into the surrounding environment. And of course, if there's an off gas in the surrounding environment, it could be dangerous to humans, or even be flammable or explosive, dangerous to the surrounding structure, and so ventilation would be required. If that's not the case, then it would not be required, but it has to have the clearly marked label stating that ventilation is not required. And then 625.15 C, dealing with ventilation required, is the same thing. Okay, if the supply equipment is listed or labeled as suitable for charging electric vehicles that require ventilation, the ventilation must be included. Okay, and it has to be clearly marked, according to code, as ventilation required, those exact words, and it's got to be visible even after it's installed. (625.17) cords and cables. 625.17c more particularly deals with the overall cord and cable length. They shall not be longer than 25 feet measured from the coupler back unless a listed cable management system is used. 625.19 automatic de-energization. This, of course, is going to be meant to protect the people and the structure in case the cord fails and falls into a wet or flammable environment. The electric vehicle charging equipment has to automatically de-energize the connector and conductors in the case of severe strain or in the case that the cord gets pulled out. 625.22 personnel protection system. They shall have a means of disconnect in the cord or on the attachment plug for personnel protection. If it is in the cord, it can't be any further than 12 inches from the attachment plug. Notice the picture here. And the Gfci protection would be optimal at this point, of course, on the circuit, and it would be, certainly located inside of the attachment cord or the plug. In addition to all this, the entire circuit has to have Gfci protection. Part 3, installation. (625.40) overcurrent protection. Being sized for continuous duty is mentioned in this section here as well as in 625.41. Overcurrent protection for circuits supplying electric vehicle supply equipment must have a rating of not less than 125% of the maximum load of the electric vehicle supply equipment. They shall also be sized for continuous duty. 625.41 rating. Charging loads for electric vehicles are considered to be continuous duty and is sized off of the electric vehicle supply equipment rating. 625.46 loss of primary source. This section is pretty easy. If you lose your primary source of power that's feeding the charging equipment, you certainly don't want the power to start feeding backwards from the car through the charging equipment into the circuit in the house. That's all we're talking about here. (625.50) Location. What about the height requirement? The coupling means the electric vehicle supply equipment must be located at a height of not less than 18 inches and not more than 4 feet above the floor. So we're talking the coupling means has got to be in that range. So between 18 inches and 4 feet above the floor. Location. The electric vehicle supply equipment must be located so that it permits direct connection from the vehicle connector to the electric vehicle. Okay, obviously, no uses of extension cords or anything like that are going to be permitted. 625.52, talking about ventilation again. The ventilation not required. Mechanical ventilation not required for electric vehicle storage batteries or equipment where it has been listed or labeled as suitable for charging electric vehicles indoor without ventilation. Okay, again, it has to be marked ventilation not required. 625.52, dealing with the ventilation being required. Okay, if it's suitable for charging indoors, but it has to have ventilation, it's got to be clearly marked. Ventilation required. And again, just as before, it has to be visible even after the installation. Article 640. Moving on. Audio processing, amplification, and reproduction. (640.1) talks about the scope. And as all of the other articles, the scope covers your equipment and wiring for audio signals in a general sense. Gives you an idea of what's to be found in this chapter. Article 640 covers equipment and wiring for audio signal generation, amplification, recording, processing, and reproduction. It includes sound for public address systems and includes temporary audio systems like concerts. Some examples where you may find audio systems covered by this article would be hotels, restaurants, offices, auditoriums, churches, and schools. (640.1) B. What's not covered? It does not cover the installation of fire or burglary alarms. (640.2) Definitions. Abandoned cable. A cable that isn't terminated and isn't identified for future use with a tag. Amplifier. Electronic equipment that increases the current or voltage potential or both of an audio signal and is intended to be used with another piece of equipment. Auto transformer. A transformer with a single winding and multiple taps intended to be used with an amplifier, loudspeaker, signal output. Audio transformer. A transformer with two or more electrically isolated windings and multiple taps intended to be used with an amplifier, loudspeaker, signal output. 640.3 Other articles. circuits and equipment shall comply with 640.3a through M. And keep in mind, penetrations have to be closed up, as though no hole was ever made. If it requires a fire stop rating prior to it, you have to make sure that it has the fire stop rating after it, because A originally begins with the spread of fire and fire products of combustion, and it says 300.21 applies. So we're talking about other articles here, and we're talking about the applicability of these specific other articles to Article 640 dealing with the audio installations and operation of equipment. So we're basically saying if you make a hole in a structure, that structure, if it required fire stop before, it has to have fire stop installed when you're done. 300.21 says electrical installations in hollow spaces, vertical shafts, and ventilation or air handling ducts have to be done so that you don't increase the flame spread potential. Pretty straightforward. B. Ducts, plenums, and other air handling spaces. See 300.22 for spaces that deal with environmental air. They shall be plenum rated unless they're installed via a wiring method accepted in Chapter 3. When it comes to 300.22b, we should probably look at that. 300.22b, wiring in environmental air ducts. Ducts that carry heating and cooling and ventilation are only allowed to have wiring methods in or through them if it's necessary to make the equipment operate properly or accessory equipment operate properly, or if the product is listed for the installation and the AHJ allows the installation. That's a two-step process. If it's listed and the inspector allows you to do it. 300.22 does have some exceptions in it. 300.22c exception allows passing through joists or studs used in environmental air. .3, still in other articles. Hey, we're going back now. We just took a look at 300.22 for a second. Okay, we looked at A and B because they were very pertinent and they were very common. Okay, the rest of these are somewhat common for some of them, and other ones are a little more obscure, so we're probably not going to look into each one of these in the detail that we did the ones before. So let's look at this. C, cable trays. You'll see Article 392. D, hazardous locations. We spoke about that just a short while ago. See Chapter 5, Article 500. E, assembly occupancies. See Article 518. Theaters, you would see Article 520. Carnivals and circuses, see Article 525. And motion picture studios, see Article 530. To continue on, I will be pools and fountains. See Article 680. J, combination systems, used when the AHJ allows the audio system to be combined with the fire alarm system. See Article 760. K is antennas. See Article 810. L, generators. see Articles 445.10 through 445.12 and 445.14 through 445.16 and 445.18. If it's a portable generator that needs to be grounded, see Article 250.34. And last but not least, M, dealing with organ pipes. You'll see Articles 650.4 through 650.8. And again, not to diminish any of these ones we didn't go into detail in. These you can detail on your own. You should have access to this program for at least a while after you're done completing it. So you'll be able to go back and do some self-study on this. Okay, the point here was to give you some examples in the beginning, which we did in A and B, which we referenced back to Article 300 and prior to that even. So looking at this section of the code requires some finesse. I mean, we're talking about audio wiring here, and a lot of people don't know exactly what's in the code book that deals with audio wiring, let alone the amount of referencing back and forth that it takes to actually properly do it. So that's why we're talking about it right now. You have several areas that will need to be referenced in order to properly install your audio cables. Moving on to 640.5, access. Access to the equipment shall not be impaired because of panels, including ceiling panels or accumulation of wires. .6 deals with mechanical execution of the work. Okay, look, when you're out there on the job site and you're putting in these audio cables, it shouldn't look like you closed your eyes and threw them straight up in the air like spaghetti string. They should be put together in a neat and orderly fashion, and really the way that it ends up looking is going to be in the eye of the beholder. You're going to say, okay, this is the best that I can do, and the authority having jurisdiction has in his mind what's acceptable to the area that he inspects for, and hopefully you have the meeting of the minds. Sometimes this stuff is overly neat, and in reality, that's the way it should be. The best job we can do, best foot forward each time. So let's look at some of this stuff. The equipment and cabling must be installed in a neat and workmanlike manner. Exposed audio cables have to be supported in a way that they'll not be damaged, and by listed hangers, straps, etc. You see Articles 300.4 and 300.11a for some guidance on that. Accessible areas of abandoned cables shall be removed, and cables installed for future use have to be marked with the date of identification for future use and the date of intended use and any additional information that's pertinent to the job. .640.10 Audio systems near bodies of water. .640.10a Branch circuit power. Audio system equipment supplied by a branch circuit shall not be located within 5 feet of the inside wall of a pool, spa, hot tub, fountain, or tidal high water mark. Also, must be Gfci protected as required by the other articles. So the other articles are still applying here when we talk about Gfci protection. Part 2. Permanent audio system installations. 640.21 The use of flexible cords and cables. Flexible cords and cables are permitted between speakers and branch circuits, between speakers and amps or just speakers, between equipment and power supplies for other than branch circuit power like transformers or storage batteries, and between racks and the premises wiring system. Okay, the requirements here also state that for the permanent audio installations, you shall comply with Article 725. Article 725 specifically deals with power limited circuits. The difference between permanent and temporary installations is that you have to take into account Article 400 when dealing with temporary installations in those matters where you're going to be taking the stuff down and moving it around. Article 400 deals specifically with requirements for flexible cords and cables. 640.22, the wiring of equipment racks and enclosure. Metal racks and enclosures shall be grounded, whether permanent or temporary, doesn't make any difference. Okay, they don't have to be bonded if the rack is connected to a technical ground. Part 3, portable and temporary audio system installations. Boy, what a nice setup we've got here. 640.41, multi-pole branch circuit cable connectors. Some things to keep in mind in supplying power in temporary situations. Cords and cables cannot have tension on them that's transferred to the connections when connected to the equipment and powered up. It should go without saying there. The power supply cord shall have the female end connected to the load. Okay, so now we're getting a little bit more chintzy in our requirements here. We're getting real specific. The cord has to be rated in amps and be constructed so that dissimilar rated devices cannot be connected together. 640.42, the use of flexible cords and cables. Flexible cords and cables are permitted in these areas. Okay, but in looking at these, 640.42 B, C, and E all have to use extra hard usage cords or cables for the temporary use. The requirements here also state that for the permanent and temporary audio installations, you shall comply with Article 720 or 725, excuse me. Again, Article 725 specifically deals with the power limited circuits. So, looking at these, flexible cords and cables are permitted between speakers and branch circuits, between speakers and amps or just speakers, between equipment and power supplies other than branch circuit power like transformers or storage batteries, and between racks and the premises wiring. Now, where is this different than what we talked about earlier? In 640.21? Well, there are just a few really different examples, because before we were talking about permanent audio system installations in Part 2 and 640.21, which dealt with very similar requirements as we're seeing here, whereas now we're not. Now we're dealing with portable and temporary audio system cables. So if this portion of the presentation seems like the same thing you just learned, remember, it's a little bit different because it's dealing with portable and temporary, whereas what we talked about just a second ago was dealing with permanent installations. Chapter 7, Special Conditions. Article 700, Emergency Systems. 700.1 deals with the scope of this chapter. This article applies to the safe installation, operation, and eventual maintenance of emergency systems for supplying power or lighting or both in a power outage. (700.2) Definition. Okay, we're going to look at the definition of an emergency system. Those that are legally required and classified as emergency by the state, federal, and local authorities. They're required to supply power and or lighting in case of a power outage. And we see these most often in public facilities, whether it be office buildings or areas that are frequented by the public. 700.3 Tests and maintenance. To keep systems operating the way they should be, you've got to conduct some tests. Okay, so what are those tests? Conduct a witness test. Complete the test of the system by the AHJ. You've got to have them tested periodically. Those are intervals that are accepted to the AHJ. Do battery systems maintenance. Make sure the proper charging and operation of the batteries. And test under a load. Make sure that the system is tested under its maximum anticipated load. So when you're looking at this, you've got initially here in the A section, the witness test. The whole system is tested by the AHJ, and then it's got to be followed up periodically with whatever the AHJ says is acceptable for the intervals, just to make sure it's working the way that it should. And then you got to check to make sure that the batteries are still in good repair. And you've got to test it under a load. Give it the maximum possible worst situation load that it could be operating under, and that's when you want to test it. 700.6 Signals. Signals shall be provided where possible to indicate derangement, what's not working in sequence or properly. Carrying a load, that the battery is carrying the load. That is not functioning, that the battery charger isn't working properly, and ground fault, that a ground fault has occurred. And D only applies to solidly grounded Y systems, so three-phase Y systems that have more than 150 volts to ground, that have circuit protected devices rated at least 1,000 amps. So, in looking at this stuff, what are we actually talking about here? We're talking about emergency systems, and we're talking about the signals. Okay, so the signals that we're talking about here are what happens when a problem occurs with your emergency system. Okay, so the emergency system, what they're saying here in the different sections, should signal you if it's not working properly in sequence. Okay, so things are out of order. If the battery's carrying the load, which means that the power has been cut, or it's failed, and now the battery is working. So if the battery is working in a non-emergency situation, or an emergency situation has occurred, but very little indication is given because of the lighting sequence, the battery carrying the load should be indicated to the people around. So you've got to have some sort of signal on that. And if it's not functioning properly, if the battery charger is not functioning, it won't charge the batteries in an emergency situation, that's going to cause an issue. So you have to know about that even when a non-emergency is happening. Okay, so general everyday business is running, it's operating, and the battery charger stops working. They should know about that so they can get it fixed before an emergency actually occurs. And then a ground fault. If a ground fault has occurred, but here, like we talked about, it's there's very specific circumstances here. A three-phase Y system, and only if you've got more than 150 volts to ground. Circuit protective devices rated at least 1,000 amps. 700.7 Signs. 700.7b Grounding. When removing a grounding or bonding connection in normal power source equipment, it interrupts the grounding electrode conductor in the alternate power source. So a warning sign has to be posted at the normal power source equipment saying, warning, Shock hazard exists if grounding electrode conductor or bonding jumper connection in this equipment is removed while alternate source is energized. (700.8) Surge protection. A listed surge protective device shall be installed in or on all emergency systems. Okay, no different than most other systems. Part 4, emergency system circuits for lighting and power. These are more specific. 700.15, loads on emergency branch circuits. Emergency circuits must supply no loads other than those required for emergency use. Okay, so this is very specific in saying that you're not going to tap into the regular lighting load in order to supply your emergency load. This means no other non-emergency appliances or lighting are going to be on that load. 700.16, emergency illumination. The emergency illumination system shall include all required means of egress lighting. Okay, you'd hate to be inside the interior of a building where there's no window lighting or any kind of lighting and have to get out of that building. So what they're saying here is you've got to light the way out, the egress lighting. Exit signs and all other necessary lighting also has to be lit. It has to be designed so that any individual light failure will not leave an area that is required to have lighting dark. This also includes the area where the indoor service or building disconnect is located as well. (700.19) multi-wire branch circuits. Very simple. Multi-wire branch circuits are not allowed for emergency power and lighting circuits. Chapter 8, Communication Systems. (800.44A4) clearance. Fairly common setup that we've got here. Supply service drops and sets of overhead service conductors that operate up to 750 volts that run above, but parallel to communication service drops, have to have a minimum of 12 inches of separation anywhere. This includes the attachment to the building. Minimum of 12 inches separation, no matter where it is. The idea, of course, is to maintain enough distance that you eliminate the possibility of induction and as well nuisance interference on the communication wires. Okay, we've all seen horror stories before of lots of different wires run lots of different places. I'd imagine that their cable reception is probably not the best in some of these environments. (800.44B) above roof slopes. You have to maintain at least 8 feet of clearance vertically above all roofs. There are exceptions. Auxiliary buildings like garages, roofs sloped no less than 4 inches by 12 inches, and overhangs on roofs. Roofs that are sloped no less than 4 by 12 inches are allowed to get no closer than 3 feet. Okay, so the 8 foot is actually diminished to 3 feet. Clearances for overhangs on roofs are reduced to 18 inches as long as no more than 4 foot of communication service drop conductors pass above that overhang. (800.49) metallic entrance conduit grounding. When entering a building with communications entrance wire contained in rigid or intermediate metal conduit, the wire shall be connected by a bonding wire or grounding electrode conductor to the grounding electrode. Part 4. Grounding methods. 800.100a. Bonding conductor or grounding electrode conductor. The bonding conductor may be insulated or bare and must be of copper or listed corrosion-resistant material. The bonding conductor shall be no smaller than 14 gauge and no longer than 20 feet. A separate ground rod for the communication system can be installed but must be bonded to the structural grounding electrode. It must be run as straight as possible and protected from damage. 800.100b1. Intersystem bonding termination. The ones you see here in the pictures, boy, are those nice. They're very slick looking. If the building is required to have an intersystem bonding termination, see Article 250.94, the bonding conductor for communication systems shall be connected to it. Great example. (800.100b2) has ground but no intersystem bonding termination. If the building is grounded but has no intersystem bonding termination and isn't required to, you shall connect to the nearest structural ground, grounded metal water pipe, power service accessible means, Article 250.94 for reference, non-flexible metallic service raceway, service equipment enclosure, grounding electrode conductor or its metal service enclosure, and grounding electrode conductor that's grounded to an electrode. Remember, on the water pipe, you have to have a water pipe that's in direct contact with the earth, and it has to be connected within 5 feet of its entrance into a building. So direct contact to the earth, 10 feet, but you also have to connect to it to make it a valid ground within 5 feet of its entrance into the building. Okay, and one thing that we've said as a basic underlying tone throughout all of the electrical classes that we provide is please make sure you check with your AHJ. Your inspector has to be okay with any of these means. There's some municipalities that don't require any of these or only require more than one as acceptable. 800.100b3. No ground and no intersystem bonding termination. If the building is not grounded and has no intersystem bonding termination and isn't required to, you shall connect any of the following individual grounding electrodes found in 250.52a 1 through 4. Could be a water pipe, a metal structural frame, could be concrete encased, a grounding ring, a rod or pipe that's at least 5 foot long in direct contact with the earth, no closer than 6 feet from any other structural ground. Bonding of the electrodes, 800.100d. You have to use a minimum 6 gauge wire if bonding the communication system grounding electrode to the structural grounding electrode. Article 830, broadband. (830.100b3). No ground, no intersystem bonding termination. Requirements are very similar to the other communication wires with a couple of minor exceptions. Here's one. If you install a separate ground rod for the broadband system, it only has to be 5 feet long and 1/2 inch in diameter. So you don't have to maintain your 8-foot ground rod or anything like that. So when you're looking at that, you've got broadband requiring 5-foot ground rod, and you've got a DSL system that's going to require a 6-foot ground rod, and you have the normal ground rod for the structural portion of the building that's maintained at 8 feet, and you have a lightning rod that's maintained at least 10 feet. So keeping all of these straight can really be a challenge, but there are diminished amounts when no other is available.
Welcome to the NEC Essentials. This is a 6-hour program designed to get the user the CEUs needed in order to renew their license. At the conclusion of this program, you'll be presented with a certificate that you can print or save to your computer, and that certificate will be used as your proof of joining us today in this class. And most likely in your jurisdiction, that proof will have to be sent to your licensing committee in order to collect your CEUs. Thank you, and we'll see you on the other side.